Hello there, and welcome to the Sleepy Science Channel. Tonight, we're diving into one of the universe's most beautiful paradoxes, space-time. Before we begin, take a deep breath, dim the lights, and maybe put your phone on silent. If you enjoy these calm explorations of reality, feel free to like, subscribe, or share a quiet thought below. It helps more sleepy souls find their way here. Picture it: space-time, the invisible fabric of existence, stretching beneath every star, every atom, every heartbeat. It's not just a background where cosmic drama unfolds. It's the stage, the script, and sometimes the director. Every motion you make, every tick of the clock, happens because space-time says so. It's basically the universe's operating system, elegant, invisible, and occasionally glitchy. Imagine a giant sheet of fabric stretched tight. Drop a planet on it, and the fabric bends. That curve, that's gravity, not some mysterious pulling force, but simply matter telling space how to curve, and curved space telling matter how to move. Einstein didn't just rewrite physics, he gave the universe a personality, smooth where it's calm, wrinkled where it's stressed. And when those wrinkles shake, that's when we get gravitational waves, ripples in space-time itself, rolling out from colliding black holes like echoes through the cosmic sea. Somewhere out there, galaxies are dancing, and space-time hums their tune. Even here, on this quiet blue planet, you're floating on that same trembling fabric, carried gently through the dark. Space-time isn't just a backdrop, it's alive with geometry and rhythm. It curves near stars, stretches as the cosmos expands, and keeps everything in motion, from the birth of atoms to the spin of galaxies. Without it, there would be no where, no when, no you, just chaos without coordinates. For centuries, people thought space and time were two separate things. Space told you where something is, time told you when. Then along came Einstein, waving his equations like a cosmic revelation, and said, "Surprise, they're married now. Every step you take through space is also a step through time. You can't move through one without moving through the other." And that's where things get deliciously strange. Move fast enough, and time itself begins to slow down. Hold a clock while speeding through space, and it ticks slower than one on Earth. You wouldn't notice, but the math would. To space-time, speed and time are in a constant tug of war, and you're the rope. Even emptiness isn't truly empty. The vacuum of space hums faintly, like a cosmic whisper, stretching and flexing with unseen energy. What looks like nothing is actually the quiet breathing of the universe. Space-time isn't watching the show, it is the show. So tonight, as you sleep, remember, you're not just lying in your bed, you're resting on a curved patch of space-time, orbiting a star, spinning through a galaxy that's racing across an expanding universe. Sleep well, traveler. The cosmos has you gently in its arms. In a universe brimming with mystery, the surprising idea of a four-dimensional coordinate system emerged, merging space and time into one harmonious dance. Imagine two quantities, twirling together, ensuring the laws of physics do a pirouette of uniformity for everyone. Suddenly, our mundane perspective shifts, unearthing a reality that's far more interconnected than we ever imagined. One giant leap for our understanding. Courtesy of Einstein's brainwave. Einstein pulled a proverbial rabbit out of the hat, catapulting our understanding of motion, space, and time into uncharted territories. Before his revelation, scientists were convinced these measurements were solid, universal truths. But who would have thought that the speed of light would create a cosmic traffic jam? Everyone has to agree on that speed. As Einstein unraveled this truth, the very fabric of reality began to stretch and bend like a circus performer balancing on a tightrope. With each graceful twist, it became clear that time isn't just ticking away uniformly, oh no. For the moving clocks, it's a different ballgame. They operate at a pace more leisurely than their stationary cousins. And distance, well, let's just say it shrinks along with the traveling motion, like your favorite sweater after a spin in the dryer. And don't forget the wild ride of simultaneity. It's all up to the context of the observer, reality. My friends, just got a whole lot wilder. Einstein didn't just toss mechanics, light, and gravity into a cosmic blender. He crafted an elegant fabric of geometry, aligning the universe under its precise rules. No hidden strings or invisible forces here. For over a century, this framework has stood the test of time, constantly reaffirmed by observations. From stars bending light to satellites zipping through the heavens, ensuring scientists find no loose threads to unravel. In this geometric wonderland, Gravity struts its stuff not as a mysterious force but as a curve in space-time. Instead of pulling us down, gravity is more like the universe's way of letting us take the scenic route as we orbit around massive bodies. When you toss that ball, it's not being unfairly dragged. It's simply gliding along the path that the Earth's mass meticulously lays out like a cosmic GPS guiding your every move. And just wait, satellites are the daring skydivers of this space ballet, perpetually falling yet never landing. They maneuver through space-time with grace, seamlessly avoiding the ground in a perfect cosmic game of tag. And light has found its way to twist and curve around massive objects as if saying, "I see how it is, let me follow this curve gracefully." As we navigate this intricate dance of motion and structure, we realize that every move we make is tightly woven into the fabric of mass and energy. It's a conversation where space-time says, "Hey matey, this is how you curve," and matey responds, "Alright space-time, here's how I'll move." In this wonderfully wacky universe, everything, and we mean everything, is interconnected, turning what we thought we understood on its head. In the fascinating realm of physics, John Wheeler's phrase becomes the life of the cosmic party, brilliantly capturing the dance of general relativity. Imagine a universe where matter and energy are the ultimate party planners, bending and curving space-time like a fun balloon sculpture. The fun doesn't stop there. This dynamic duo dictates the way that everything travels through their gravitational playground. The beauty lies in the mutual relationship, as they constantly readjust their dance moves, ensuring no one is left out of the stellar shindig. Gathering mass causes a cosmic ruckus, creating wells and ridges in the geometric landscape of space-time that influences how particles and light get their groove on, like a bunch of friends forming a conga line. Each addition changes the shape and energy of the group. The choreography is dictated by Einstein's field equations, harmonizing the contents of the universe with a stunning array of mathematical relationships that give structure to this celestial jamboree. Just picture a multitude of planets, stars, and cosmic whirling dervishes moving across the sky, driven by the conversation between their mass and the very fabric of the universe. But the plot thickens. Space-time is no rigid wallflower. Instead, it twists and warps around celestial bodies, putting on quite a show. As the universe expands, this flexible geometry stretches out, allowing galaxies to drift farther from each other. Contrast this with a graceful sprinkle of black holes, spinning their influence like cosmic DJs, crafting intricate patterns of frame dragging that pull matter and light into mesmerizing spirals. The universe isn't just a cosmic flat surface, it's a vibrant dance floor brimming with undulating energy and excitement. Now, let's talk about the majestic light show that unfolds as light from far-off stars passes through different gravitational fields. Like gravity's magic trick, light bends and shifts, unveiling the invisible contours of space-time. These cosmic distortions aren't just for show, they are measurable and predictable, illustrating how intimately tied the fabric of the universe is to its inhabitants. The spectacle of gravitational lensing reveals how advanced the universe's geometry is, with each swirl of light adding to the tale of cosmic cooperation. The plot twist doesn't end there. Time itself is on the guest list. It turns out, space-time has its own rhythm. Near massive bodies, time slows down, making clocks tick like they're caught in slow motion, while their far-off counterparts hum along at a quicker pace. Imagine twin siblings, one living near a massive star, while the other frolics in the cosmic suburbs. Their age difference could become quite the conversation piece. Those near great mass feel time stretching and bending around them, illustrating the distinct ways gravity affects the flow of existence. This waltz between mass, energy, and the flexible geometry of space-time is not merely theoretical. It creates a vibrant backdrop for orbits, tides, and the majestic expansion of our cosmos. Every orbit taken by planets, every turn of celestial bodies is choreographed by the grand interplay of mass and geometry, all while the universe sighs in self-consistency. So, next time you look up at the night sky, remember that what you're witnessing is not just an array of stars but a delightful dance, where every participant knows its role to perfection. Gravitational time dilation is a quirky phenomenon, like discovering your favorite snack has mysteriously shrunk in size. Atomic clocks on Earth and those floating around in satellites run at different speeds, not because they're being lazy, but due to their positions in the gravitational well of our planet. a clock on the ground just can't keep up with its airborne buddy. This hilarious difference in timing is why GPS systems need to make those little adjustments. We can't have our maps leading us into a black hole, can we? Now, let's talk about black holes, which take this gig to extremes. To someone watching a friend get sucked into one, time seems to freeze as the friend approaches the event horizon. A cosmic hold on will make it moment. But for the lucky individual plummeting in, everything feels quite normal. Gravity isn't just a force, it's like time's fashion designer, tailoring its passage based on where you are in the universe. So, whether you're deep in the Earth's core, orbiting in space, you can bet time is shaping up differently for you. Thinking motion won't influence the tick-tock of your life. Think again. According to special relativity, zooming through space like a cosmic race car slows down time just for you. It's called time dilation. And believe it or not, science has run tons of experiments to back this up. Think speedy particles and super accurate atomic clocks on aircraft. Picture party animals, like muons, living it up in the upper atmosphere, existing a whole lot longer when they're boogieing near the speed of light than when they're just chilling. So, if you could hop into a speedy spacecraft, you might experience just a handful of blissful years on board while centuries slip by on Earth. It's like a cosmic version of I'll Be Right Back, but with your relatives aging without you. This overlapping of motion and time proves that everyone's experience of duration is uniquely walk-talk about your personal timeline. And here comes the kicker, light. No matter how fast you're speeding along or in which direction you're soaring, light zips ahead at the same speed. You could be racing in a rocket or stuck in traffic trying to parallel park light, wouldn't even break a sweat. Its constant speed forms the backbone of modern physics, holding the whole relativity marvel together like the ultimate glue in the universe. In relativity land, space and time can stretch, contract, and breathe to keep the speed of light steady. It's like the universe knows a good balance when it sees one. Every experiment aimed at this cosmic dance gives us more wild confirmations that space and time are in cahoots, keeping the rhythm of our adventures intact. So, buckle up, folks, time and space are taking us on a wild ride. Michael Elson and Moley paved the way for a thrilling exploration of light's behavior, ultimately revealing that nothing, and I mean nothing, can speed past it. Light is like that finicky speed limit sign on a cosmic highway. No one gets to outrun it. Travel is a quirky game, with each object moving toward that luminous finish line differently, all thanks to its energy level. This universal consistency is the glue that holds the wild equations of physics together, connecting everything from atoms to galaxies in one grand cosmic dance. Imagine a universe where time and distance lose their meaning. Total chaos. Right, thankfully, the constant speed of light is like the ultimate anchor, allowing scientists and stargazers alike to describe the wild ride of motion, energy, and time in a coherent manner. It's the magician behind the curtain, transforming complex ideas about mass and energy into a simpler understanding of the world, ensuring that our cosmic laws stay intact and reliable. Without it, we might as well be lost in a never-ending labyrinth of confusion. This remarkable speed of light is the unifying factor among electromagnetism, relativity, and quantum theory, creating a dazzling tapestry of scientific connections. It's not just an abstract concept. It practically dictates how quickly we can receive signals from twinkling stars and the length of dramatic waits for cosmic events to unfold. The very definitions of the meter and the second cling tightly to light's steadfastness, giving it a critical role in the very fabric of our existence. Speaking of critical roles, have you considered how your GPS thrives on the genius of light's constancy? Modern navigation systems are like high-tech wizards in the sky, depending on satellites orbiting Earth, each equipped with atomic clocks that measure time with astounding accuracy. However, here's the catch. Those clocks up there tick at a different pace than those we have on the ground. It's like a cosmic dance-off, with the satellites moving swiftly, which causes their clocks to slow down due to special relativity. Meanwhile, thanks to general relativity, these higher altitude clocks also tick faster since they're further from Earth's gravitational grip. The cosmic comedy of it all leads to a daily timing hiccup of approximately 38 microseconds. While that sounds minuscule, without the proper corrections, we'd be floundering with location errors that could stretch out a few kilometers every single day. Imagine being an entire kilometer off just because you didn't take relativity's quirky effects into account. Astoundingly, engineers have mastered the art of synchronizing satellite and ground clocks, working behind the scenes to prevent our navigation systems from spiraling into chaos. So, when you whip out your phone to determine your whereabouts, remember that it's not just luck. Einstein's groundbreaking insights into the nature of space and time are tirelessly at work in the background, keeping you steady on your digital journey. Even our daily routines must bow to the unraveling mysteries of the universe orchestrated by light. Time is a sneaky little rascal, especially when it comes to mountains and valleys. Picture this: on a mountain peak, time is like the flashiest clock on the block, ticking away just a tad faster than its sluggish cousin down in the valley. This quirky phenomenon, known as gravitational time dilation, means that gravity, in all its heavy-handed glory, actually stretches out time a bit. So, if you're hiking to the top, just remember, your head's getting a mini time travel upgrade while your feet lag behind. Now, don't get too excited. This time difference is small, like Taylor Swift's "We Are Never Ever Getting Back Together" small. But scientists have adorable little atomic clocks that can pick up this difference with precision. Imagine two synchronized clocks on a shelf, one perched high, soaking in the sunshine, and the other sitting comfortably in the shade. Those clever scientists found that, lo and behold, the top clock was ticking away faster. It's like running a race where the finish line is just a tiny step above the ground. The implications here are a big deal for techies and scientists. Picture this: over the course of your life, your noggin is actually aging just a smidgen quicker than your toes. It's like your head is throwing a tiny party, while your feet are still hitting snooze. These minute differences remind us that gravity and time are like dance partners, swirling around in a gravitational tango, elegantly entwined in a cosmic embrace. Speaking of dancing, let's talk about light. Just when you thought light was a straight shooter, it turns out to be a little bit of a diva. When starlight struts past a massive object, like our sun, it bends ever so slightly, not because it's being pulled, but because space itself has its curves. This cosmic catwalk was first observed by astronomers during a solar eclipse in 1919, and boy, did they find some surprises. Stars seem to play a game of hide and seek, appearing out of their usual positions. Those observations were like a gold star for Einstein, confirming his grand theories of general relativity. Suddenly, the universe felt much more sophisticated, as if it had donned a tuxedo and slicked back its hair. Today, scientists still strut their stuff using this funky light bending to peer into the vast, enigmatic universe. They can spot clusters of galaxies and even map out regions filled with mysterious dark matter that's playing hide and seek with light itself. Every twist and turn in light's path, every distorted image we see in the cosmos, is a clue. Think of it like a scrapbook of spacetime's little secrets. It tells us gravity isn't just a player in the motion game. It's also the ultimate maestro, guiding light on a grand adventure through the theater of the cosmos. Gravitational lensing is like nature's way of putting on a cosmic show, where space turns into an extravagant magnifying glass. Imagine light from a distant galaxy floating by a gigantic cluster of galaxies. The massive gravitational force of that cluster bends and tweaks the light, much like how you'd twist a balloon into funny shapes. Depending on how all the celestial bodies align, we might see arcs, rings, or even multiple versions of that galaxy peeking through the cosmic curtain. Astronomers love this dramatic flair because it helps them study galaxies that would otherwise hide in the shadows too faint or too far for our standard telescopes. Thanks to this cosmic magic trick, we not only get an incredible view of these distant worlds, but also a peek into the mysterious realm of dark matter. This elusive substance makes up most of the mass in galaxies, and by analyzing how light is distorted, scientists can sketch out maps of these ghostly structures shaping the universe. So, think of gravitational lensing as the universe's very own high-tech magnifying glass, allowing scientists to pry into the furthest corners of the cosmos. It's like holding a giant cosmic telescope that reveals all the hidden gems of space-time, amplifying not just images but the mysteries of existence itself. Without this phenomenon, those shy galaxies might remain forever hidden from our curious eyes, shrouded in the darkness of space. Now let's dive into the wonders of black holes, the ultimate cosmic party crashers. When a massive star runs out of nuclear fuel, gravity decides to throw a wild farewell party, crushing the core into an extreme density. The result, a black hole, where space-time crumples like old paper, and not even light can manage to escape the crush. Picture this. The boundary surrounding a black hole is called the event horizon. This isn't a solid wall but an elusive curtain, marking the spot where escape becomes impossible. It's the point where the gravity's pull is so intense that even light takes one look and says, "Nope, I'm out." Once crossed, anything, be it matter or radiation, is tangled in black hole's embrace forever. To an observer watching from a safe distance, an object spiraling into a black hole seems to dawdle, slowing down and fading, as if attempting to stretch time. But inside, it's a different story. For that object, time moves along like a straight highway, racing toward the singularity at the heart of the black hole, a mysterious point where density and curvature reach mind-boggling levels and our known physics throw up their hands in confusion. In the grand scheme of the universe, black holes aren't just mysterious voids. They are fascinating regions where space-time itself has folded in on itself. They're the quirkiest residents of the cosmic neighborhood, drawing everything close, yet leaving tantalizing questions in their wake. With each new discovery, we inch closer to unraveling the enigma of these celestial wonders. Buckle up, because the universe is full of surprises waiting just beyond the event horizon. Imagine standing on the edge of the universe, watching an object tumble into the abyss of a black hole. From your vantage point, it seems to slow down, fade, and freeze in a dramatic cosmic ballet. But for the object itself, it glides smoothly onward, blissfully unaware of the looming doom. This cosmic dance is a reflection of Hawking radiation, a quirky idea from quantum theory that hints at black holes quietly losing mass, one tiny photon at a time. Now, let's talk about the event horizon, that peculiar line where the rules of physics go to hang out and have a cocktail. It's the cosmic boundary that separates the knowable universe from the great unknown. Think of it as a cosmic keep-out sign from a universe where relativity and quantum mechanics try to play nice but inevitably end up arguing about who gets to decide what's really going on. Beyond this point, you're on your own. Good luck with your space-time adventures. Inside this strange realm, space and time pull a fast one on you, flipping their roles like the best magician at a birthday party. In the belly of the black hole, gravity is so intense that time bends and folds upon itself, transforming motion into a one-way ticket to the singularity. There's no spontaneous escape. All roads lead inward, like a cosmic game of going in circles, except you can't ever go back. To those brave enough or unfortunate enough to fall in, the experience is bewildering. Outside observers watch in awe as the object seemingly freezes at the event horizon. But inside, it's business as usual, no panic. Just a serene slide into oblivion. This funky twist demonstrates just how flexible our concepts of time and space are, reminding us that even the universe has a sense of humor when it comes to its geometric tricks. The singularity is where things take a turn for the really weird. It's not just a point in space, but also a critical moment in time that every object inside will inevitably experience. Imagine a party where everyone is heading toward the final dance but can't quite decide when to leave. Everyone eventually ends up on the dance floor, whether they like it or not, in the embrace of a black hole. Physics as we know it crumples into a mysterious ball of confusion. And let's not forget about a lively topic, gravitational waves. These wondrous ripples in space-time are like the universe's way of throwing a massive rock into a pond, causing waves that spread out across the cosmos. Originally predicted by Einstein over a century ago, these waves went undetected until 2015, when scientists finally caught a glimpse of them dancing across the universe from two galloping black holes colliding a billion light-years away. Gravitational waves are an invitation to eavesdrop on cosmic events that don't bother to emit any light. They reveal how dynamic and fluid space-time is not some rigid backdrop, but a vibrant, elastic fabric that tells tales of cosmic happenings. Think of it as our universe's diary, where every ripple is a story of drama, collision, and perhaps a bit of interstellar hilarity, like watching a cosmic soap opera unfold. These discoveries open our eyes wider to the enchanting chaos of the universe. Gravitational waves imagine the universe plucking at the cosmic guitar strings. These wavy distortions are what happens when hefty celestial bodies dance, bump, or merge into each other. Unlike sound or light, they ripple through the very fabric of space-time, making it jiggle just a smidge. So tiny are these stretches and compressions that you'll need some super fancy gadgets to detect them. Enter LIGO, the Leonardo da Vinci of the cosmos, which first picked up a signal in 2015. Talk about an attention-grabbing debut. Now, let's unpack that first stunning detection. Two black holes merging after doing the celestial search for ages. This was cosmic gossip from over 1 billion light-years away. When they finally crashed, it unleashed a tidal wave of energy greater than all the stars in our observable universe squished together. All in a blink of an eye, the universe was basically yelling, "Look at me," and astronomers were all ears, ready to eavesdrop on this galactic drama. As scientists comb through these gravitational waves, they're like intergalactic detectives. By analyzing the shapes and frequencies of these waves, they can quantify masses, spins, and how far away these dramatic encounters took place. That's right, these waves unlock secrets about cosmic events that telescopes just can't touch. It's a new frontier of astronomy where instead of peering through a lens, we're tuning in to the universe's orchestra of space-time. Every time two cosmic heavyweights collide in a dance of doom, they send out ripples across the universe like a cosmic shockwave. These waves zip through space at the speed of light, stretching and squeezing space itself. Faint echoes of these collisions are washing over us right now, subtly changing atom distances less than a fraction of a proton. To be precise, can you feel that? Well, neither can I, but LIGO can. Thanks to instruments like LIGO and Virgo, scientists can detect those minuscule tremors and piece together the puzzle of cosmic events. Each detected signal is essentially a celestial fingerprint. It tells a tale of epic smash-ups, like black holes merging or neutron stars going head-to-head, resulting in cosmic fireworks that would put July 4th to shame. So now, as we continue to listen to these gravitational waves, we're not just observing, we're vibing with the universe. Each collision resonates like a grand symphony, revealing the hidden stories of the cosmos. It's a new way to explore that which is too dark to see, and the cosmic stage can hardly contain the excitement as we unlock its mysteries, one ripple at a time. The universe is buzzing with life, a grand cosmic dance where everything moves and grooves to the rhythm of gravity's gentle pull. It's a lively symphony playing out in the vast, endless sea of space, not a silent void. Every stellar body is in a constant state of motion, with a curious notion of time weaving itself into this energetic tapestry. Who knew space could be so musical, right? In the groovy era of the 1970s, scientists set out on an ambitious adventure, launching atomic clocks aboard commercial flights around the globe. Since the laws of relativity dictated that moving clocks tick more slowly than their stationary counterparts, these scientists were on a quest to test Einstein's bold predictions. And, when they compared those airborne clocks to their grounded twins, they discovered a time-warping phenomenon. The airborne clocks showed slight discrepancies, aligning perfectly with Einstein's theories. Talk about a cosmic MIC drop. But wait, there's more. These findings didn't just apply to distant stars and black holes. They popped up in our everyday lives, too, thanks to the modern technology that keeps our GPS and navigation systems on point. We rely on these time corrections. Every plane journey you take doesn't just take you through the clouds. It sends time into a fascinating spiral, altering how seconds tick by. So, next time you're jet setting, give a little nod to relativity as you zoom through the atmosphere. Also, it's quite mind-boggling to think that your head ages faster than your feet. Yes, you read that right. Because your noggin sits slightly higher than your toes, it basks in a softer grip of gravity. This means time runs just a smidge faster up there. Sure, the difference is minuscule, a mere few billionths of a second over lifetime. But scientists have measured it with impressive accuracy using their marvelous atomic clocks. And while you might think such tidbits of time play only around massive celestial bodies, they actually creep into our daily existence, too. There's a tiny gradient of temporal experience all around you, where every heartbeat is set to a slightly different clock. Thus, you're riding waves of gravity-induced time dilation every moment of your life without even realizing it. Now imagine this playful dance of dimensions. Though space-time appears four-dimensional, our minds grasp only three: a trio that includes length, width, and height. The fourth dimension, that sneaky rascal, is time, weaving in and out like a clever magician. Together, they create a wondrous structure we call space-time. So, each time you look up at the stars, remember, You're gazing at a spectacular four-dimensional spectacle of cosmic creativity. Imagine zipping through the universe like a cosmic taxi driver, swerving around galaxies, while time bends in ways that would baffle even the best navigation systems. Space and time are like a dynamic duo, not separate entities but rather woven together like the finest tapestry. Every event is a delightful concoction of a particular location and a unique moment. Two peas in a dimensional pod, if you will. Now, here's something to chew on. If you're tooling around in a spaceship and your buddy is lounging on a planet, guess what? You both see the universe differently, especially when it comes to the tick-tock of time. To you, a few seconds might feel like minutes to your pal, but no matter how different your experiences are, you both agree on the grand reality swirling around you, a cosmic cocktail of relativity uniting space-time's four dimensions in a potion of perfect harmony. Thinking of time as the fourth dimension flips the script on how we view motion and existence. It's like realizing the secret ingredient in Grandma's famous soup. It makes everything better. Every event struts around the universe with a need for four coordinates. Where and when it happened. So, when you run, dance, or just trip over your own feet, remember that you're moving through both space and time. How's that for a dance partner? And here's the kicker. Those in different motion states may slice through this four-dimensional reality differently, giving them their own take on what now truly means. It's a bit like two artists attempting to paint the same sunset. They're bound to capture its beauty in unique strokes. This funky dance of dimensions explains why simultaneity can be as slippery as a bar of soap, yet cause and effect stand tall and proud. The fourth dimension isn't just a mind-bending concept, it's the backbone of the universe's cosmic geometry. This dimension links every corner of space to every moment in history, creating an intertwined fabric of existence. So, the next time you ponder the cosmos, remember that it's not simply a vast void but a dynamic fabric of moments stitched together by the threads of time. Now, what if I told you there might be even more dimensions lurking in the universe, like the surprise ingredient in your favorite dish? Some aspiring physicists speculate there's more than just the four dimensions we've come to know and love. Theories like string theory whisper about hidden dimensions, twisted up so small they play peekaboo with our perceptions. They could be the XXL secret explaining why gravity feels a tad weaker than other forces. These extra dimensions are like an invisible hand influencing the universe while staying out of sight. Although you can't see them with your eyes, their effects sneak into our reality, possibly showing up in slight gravitational shifts or high-energy particle collisions. So keep your eyes peeled because, as we unravel the mysteries of the cosmos, we might just discover dimensions hiding in plain sight, waiting for us to unlock their secrets. The quest to uncover the universe's hidden layers is like a cosmic game of hide and seek. Scientists are scrambling to find clues that might expose dimensions curled up at subatomic levels, creating a richer tapestry of reality. It's as if the universe is hiding an expansive secret behind a very thin curtain, and these experiments could pull the curtain back, revealing a grand cosmic design. The thrill of possibility keeps them racing against time like kids at an amusement park. String theory enters the stage with a fascinating proposition. Our universe is built not from tiny little particles, but from minuscule vibrating strings. Imagine them as the ultimate musicians of the cosmos, where each unique vibration produces a corresponding particle or force to make this grand performance work. Space-time needs to pack in more than just the familiar four dimensions. We're talking about an epic 10 or even 11 dimensions that could be swirling around us. Now, you might be wondering where these extra dimensions are. Picture a straw from a distance. It seems like a basic line, right? But when you zoom in for a closer look, it reveals a cylindrical structure. That's how these microscopic dimensions operate. They're there, but they're so tightly rolled up they remain invisible to our everyday perception. It's like a magical world existing right under our noses, waiting for someone to catch a glimpse. The shape of these hidden dimensions is essential, because it determines the very nature of particles like mass and charge. These minuscule, folded dimensions exist at what's known as Planck length, an almost unfathomably tiny scale. They play a significant role in how particles interact and how forces combine, acting like master conductors of a grand symphony. While we can't observe these dimensions with our eyes, physicists are scrabbling through particle accelerators and gravitational experiments in search of indirect evidence. The excitement is palpable. Imagine the day when the universe's secrets are unveiled. Despite the challenges, string theory hasn't been shy about teasing the scientific community with insights into black holes, quantum gravity, and the very structure of our reality. The invisible dimensions could unify all known forces like gravity into one cohesive theory, homogenizing chaos into harmony. It's still a wild idea, but with every step forward, the image of a more complete universe grows clearer. Set against an ever-expanding cosmic background, one could argue that discovering these hidden dimensions may change humanity's entire perspective on existence. Think of it, an elaborate, intricate cosmic design hidden in plain sight. What we perceive as our three-dimensional world is just the tip of the iceberg, teasingly hinting at an endless array of dimensions waiting to be explored. Scientists hold their breath, hoping to map out these unseen territories and reveal the astonishing complexity that might redefine how we view our role in the universe. The narrative of our universe isn't confined to what we can see, but vibrates rich with untold stories just waiting to be discovered. As researchers continue their tireless search for these curled-up dimensions, they inch closer to unveiling the cosmic symphony that plays just beyond our understanding. Every experiment could lead us a step closer to realizing that we're mere spectators in a grand, multidimensional performance, one that holds more mysteries and awe than we ever dreamt existed. Imagine if we could glimpse the myriad dimensions beyond our three-dimensional bubble. Suddenly, reality would sprout wings, transforming mundane objects into an intermingling tapestry of connections. What if that pesky lost sock you can't find wasn't lost at all? Perhaps it's happily chilling in a dimension you can't perceive, creating an existential crisis every time you trip over that matching one. Who knew laundry could be cosmic? In this higher dimensional playground, all those seemingly isolated events we experience might be happening simultaneously. Remember that time you accidentally bumped into your ex while eating ice cream? With all dimensions in view, you'd realize that moment wasn't so isolated. It was intricately linked to the numerous events leading up to it. Your daydreams about the perfect cute meet could finally come to fruition as entire timelines twine together like a funky spaghetti hairdo. Thanks to the wonders of mathematics, we can speculate about these dimensional realms, a world where geometry is not just triangles and squares, but bizarre shapes with more sides than you can count. Who wouldn't want to hang out in a dimension where straight lines are merely suggestions? It's like entering a bizarre art exhibit where everything is elastic and logic is merely a guideline. We'd unlock secrets about everything from the twinkling stars to the brisk behavior of quarks. Now, let's address the cosmic elephant in the room, the Big Bang. Contrary to popular belief, it wasn't just a cosmic fireworks show sending particles zipping around like caffeinated squirrels. Nope, it was the grand unveiling of both space and time, a cosmic duo bursting forth from a hot, dense ball of nothingness. And here we were, thinking it all started with a simple puff, more like an epic cosmic whoosh. After this spectacular event, the universe began its dizzying expansion, spreading out like fresh butter over warm toast. Stars, galaxies, and planets formed as matter and energy cooled. Even today, we can bask in the remnants of that explosive birth, the cosmic microwave background. Imagine it as the universe's version of a soothing blanket, wrapping us in remnants of creation every time we look up at the night sky. But let's not get too comfortable. Modern cosmology likes to keep us on our toes. Space-time isn't some dull, stagnant container, oh no. It's as dynamic and evolving as a toddler with a new crayon. Asking what happened before the Big Bang is like asking what's north of the North Pole. Spoiler alert, it doesn't exist. The true start of everything is the moment space-time took its first breath, establishing all our future moments. Ultimately, the Big Bang is not just a one-time explosion but the genesis of existence itself. The day when space and time kicked off their epic road trip, leaving behind any notion of before. So, next time your eyes wander the cosmos, remember there's a vibrant, complex existence dancing just beyond your perception, a flicker of life and energy stemming from that very first moment. Mind-blowing, isn't it? Picture this. Before there was time, there was a nifty little void with no timekeeper in sight, and things weren't looking too good for physics. Trying to discern what happened before the Big Bang is about as helpful as asking what lies north of the North Pole. Absolutely nothing. It baffled scientists as they scratched their heads because the fabric of reality began to unfurl from an ultra-dense and hot state right into the glorious cosmos we know today. It was the cosmic equivalent of unrolling a space-age carpet. As the universe kicked off its stunning display of expansion, every atom, star, and neutron began their epic journey from that spectacular initial puff talk about an out-of-this-world beginning. In those early flickers of existence, time and space were like those besties who couldn't be separated, entwining themselves into cosmic chords that would lift up the universe's grand architecture. The Big Bang wasn't just your run-of-the-mill explosion, but rather the wondrous ignition of matter and existence as we know it, a real party starter. Now, you'd think the universe might have a center, right? Wrong. It's like saying your friend was the center of attention at a party when everyone was equal in their chaotic fun. Galaxies appear to be sashaying away from us in all directions, as if we had just center stage at a cosmic dance-off. But hold on, this isn't some dramatic explosion blasting into an empty void. Space itself is stretching out like taffy, making everything glide smoothly away. Let's break it down further. No matter where you stand, it seems like galaxies are getting a little more skittish by the day. The farther they are, the faster they seem to slip away. This cosmic exodus has a tantalizing symmetry. There's no VIP section in this space shindig. Everyone experiences the same Great Recession. It's a cosmic free-for-all, and it defines the very fabric of reality that we dance through. Galaxies aren't just zooming around like particles thrown in a blender. No, they're charmingly plodding at their own leisurely pace, anchored by their own gravitational forces while space-time casually expands around them. They're like little towns nestled in a growing neighborhood, where the roads are stretching farther apart but the local coffee shop remains their trusty meeting spot. So, there we have it, an epic cosmic tale where the beginning of time gives birth to an ever-expanding universe, all while galaxies enjoy an unhurried drift apart. It is space itself that's doing the stretching, and those twinkling galaxies are simply holding on tight to their gravitational connections. Who knew our universe had such a whimsical way of expanding itself while keeping the cosmic dance floor plenty busy? As space stretches like a cosmic rubber band, galaxies are sent packing well, not exactly speeding away like children on a playground, but more like dots on a balloon expanding before our very eyes. Ever noticed how light from distant galaxies has a penchant for taking a detour to the red end of the spectrum? This red shift isn't merely a cosmic fashion statement. It's solid proof that the universe is in a constant state of expansion. Over billions of years, the universe has evolved from a bustling, crowded interstellar affair to the vast, spacious megacosmos we gaze at today. If you picture galaxies as well-behaved guests at a party, they aren't really elbowing each other out of the way. Instead, they remain mostly stationary relative to their local pals. It's the very fabric of space itself that's making an enthusiastic exit. This isn't just random movement, it's a full-blown cosmic reshuffling. Imagine drawing dots on a balloon and watching them drift apart as the balloon inflates. That's essentially what's happening out there in the universe, with no overarching void or looming edge getting in the way. It's a great cosmic dance of space creation, as galaxies get more personal space without actually moving at all. The geometric nature of the universe that's the real kicker. As the universe expands, the light traversing those galactic highways gets stretched out like a yoga instructor in a warm-up stretch. This means that understanding how widely spread out the universe is can actually tell us how quickly it's expanding. It's a revelation that shakes the very foundations of what we perceive as movement in our cosmic playground. The universe is expanding just for the sake of expanding. And that, my friends, is quite the concept to wrap our heads around. Then came a twist that none of the experts saw coming. For a long stretch of cosmic history, scientists were convinced gravity had a firm grip, predicting that it would gradually slow down the universe's expansion. But, surprise, in the late 20th century, a team of astronomers took a closer look at some supernovae and gasped these celestial fireworks were dimmer than they were supposed to be, to everyone's astonishment. The universe wasn't decelerating, it was throwing on the cosmic gas and speeding up the expansion. This shocking revelation raised eyebrows across the scientific community. It meant that some elusive, enigmatic energy is swirling around, challenging gravity's throne. It turns out, this energy, dubbed dark energy, permeates the entire universe, acting as an aggressive cheerleader for expansion. This fresh twist redefined cosmology as we know it, compelling scientists to reconsider the universe's long-term fate. Forget the slow, gentle lapse of time, a wild cosmic roller coaster ride awaits. As they say, out with the old, and in with the unexpected. The underlying mechanics of the universe morphed from a predictable path into an exhilarating saga of constant change. Every time we peer into the starry abyss, we grapple with the realization that it's not just stars and galaxies out there, but a complex tapestry woven from the very fabric of space and time. With each new discovery comes an invigorated sense of wonder. Where is this universe heading next? Only time, and plenty of research, will tell. Picture this, as stars wink out of view and galaxies race away from us. They're playing cosmic hide and seek. Imagine the universe expanding at warp speed, snatching distant galaxies from our grasp, leaving us puzzling over why our stellar neighbors seem to be ghosting us. This isn't just a leisurely stroll from the Big Bang, but an exhilarating roller coaster powered by a mysterious force that scientists have named dark energy, the universe's best-kept secret. Now, don't get too cozy, because dark energy isn't about to spill its secrets easily. Picture it as that enigmatic force holding the universe in its unpredictable dance. While gravity drags celestial bodies together like an overzealous matchmaker, dark energy is the cool rebel pushing them apart, eating up around 70% of our universe's energy pie. It's the biggest slice that nobody knows how to taste. Our cosmic sleuths have come up with some wild theories about dark energy. Some think it could be a quirky property of space itself, a constant energy density that suddenly crash-landed from quantum fields. Others wonder if it might grow or shrink over time, like a mood swing after too much caffeine. Meanwhile, some even question if we've misread gravity. Perhaps it's playing us like a fiddle instead of leading a ballroom dance. Instead of just staring at this cosmic riddle, scientists are employing sleuthing skills, analyzing supernovae, and surveying the cosmic microwave background. It's all a part of chasing that slippery creature called dark energy. Even after heaps of research and decades spent peering into the cosmic abyss, they've unearthed only its effects, like tracking a phantom that leaves no footprints. What a cosmic tease. So, here we are, caught between fascination and frustration. Understanding dark energy is like trying to find Waldo in a sea of stripes. But with the stakes of the universe's fate on the line, will we keep expanding into a freezing, desolate space, or will this cosmic conundrum lead us to something more intriguing? The potential outcomes are a thrilling cliffhanger that's sure to keep budding astrophysicists on the edge of their seats. In an ever-expanding universe, dark energy is the ultimate mystery, fueling the cosmos' growth while remaining invisible and utterly bizarre. It doesn't emit photons, rub elbows with matter, or hang out with other forms of energy. It's just there, casting its shadow while driving the grand changes around us. It's like the unseen hand of cosmic destiny shaping the ultimate narrative of existence. So, whatever dark energy truly is, it's definitely one of the heavyweight contenders in the ring of cosmic enigmas. Will we ever unveil its true nature? Perhaps it'll take an expedition into the far reaches of our imagination, or a new scientific breakthrough that flips our entire understanding upside down. Until then, we'll just have to sit back, keep pondering, and maybe grab some popcorn for this grand, cosmic show. The universe's geometry is all about density, baby. Imagine the cosmos as a giant cosmic pizza, where the amount of cheesy goodness, matter and energy, dictates its shape. If that density is sky high, gravity bends space-time inward, giving us a closed universe like a big, balmy beach ball floating in space. On the flip side, low density leads to an open, satellite universe, where things just want to spread out and chill. Now, if the universe manages a perfect density balance, we get a flat universe. It's like an all-you-can-eat buffet where space refuses to curve. Here, parallel lines can be best friends for eternity, never crossing paths, while triangles play by the rules where the angles add up to a flawless 180 degrees. This stellar balance isn't something slapped on from outside. Rather, it's the universe's own mysterious recipe brewed from the ingredients it holds. To keep this flat masterpiece in check, a precise harmony between matter, energy, and the expansion rate is essential. A tad more mass, boom, expect a cosmic collapsing party. Less mass, the universe zooms off like a runaway train, making galaxy formation a distant dream. This finely tuned balance is like navigating a tricky dance floor. It's got cosmologists scratching their heads over what they call the flatness problem. Enter cosmic inflation. Stage left. Imagine a brief burst of frenetic growth in the early universe that smoothed out any awkward curvature. This was big-time expansion, like blowing up a balloon too quickly without popping it. The aftermath is a seemingly perfect cosmos, showcasing a delicate equilibrium that defines every twinkle in the night sky and every atom in your coffee cup. After all, the universe says I got this. Now, let's take a little jaunt into the world of curved space-time, where the possibilities are as wild as the rides at an amusement park. If space-time gets all twisty and turns just right, you might travel in a straight line only to loop back to where you started. It's like going on a cosmic circle tour without even needing to make a pit stop talk about cosmic convenience. This concept thrives in a closed universe, where space resembles the outer layer of an enormous higher dimensional sphere, like some celestial orb. Here, there are no edges or boundaries, just endless possibilities. Picture your adventurous spirit roaming through this infinite expanse, yet still ending up back at your starting point only after an utterly mind-boggling journey. Exploring this grand arena of the universe isn't just about chasing stars and planets. It's about understanding how these cosmic shapes influence the very fabric of existence itself. With each new discovery, we peel back layers of mysteries, all while keeping our humor intact, because if the universe has taught us anything, it's that life, and the cosmos, is a wild ride brimming with unexpected twists. So, imagine the universe is like a giant cosmic pancake, mostly flat, but with the slightest of curvatures here and there that hint at a hidden depth. If it turns out that space-time bends back on itself like a well-tied bow, we might just be living in a self-contained cosmic hug. This would mean that, unlike your last holiday destination, there's no outside world, and space and time are on an endless loop of celestial shenanigans. Who's up for some cosmic continuity? Now, before you pop the cosmic champagne, there's a potential plot twist. The Big Crunch. Picture it: if the universe is packed with enough matter and energy, gravity might decide it's time for a reunion tour. The galaxies, which have been gallivanting apart, could suddenly get the urge to pull back together. They'd slow their sassy drift, reverse course, and rush towards each other like friends who haven't seen each other in ages. The grand finale. A fiery contraction where everything collapses back to its dense, hot roots. Talk about a dramatic conclusion. But wait, after this intense cosmic burnout, some theories suggest we might just kick off a new cycle. It's like the universe's version of a reset button collapse. Then boom, here comes the expansion again. This cyclical existence is a wild ride that reminds us that space-time is a bit of a show-off. Not only does it stretch out, but it can also fold itself back up into that singular state of infinite density from which it first burst forth like a good magician's trick. On the flip side, there's the possibility of an open universe, where things just keep expanding indefinitely. If there's not enough matter and energy to rein in the expansion, galaxies will keep drifting apart like awkward teens at a dance party. Over the eons, the night sky could become as dark and empty as your fridge right after grocery shopping. Stars will run out of their shiny fuel, black holes will slowly fade away, and eventually, all that'll be left is a cold, featureless expanse. It sounds like a cosmic party that nobody shows up to. This fate, known as the heat death of the universe, doesn't exactly scream excitement. Instead, it's a scenario where everything is evenly distributed and nothing can happen anymore. Imagine the ultimate snooze fest where energy can no longer do any work, like your remote after a long binge-watching session. But don't get too gloomy. This scenario, while bleak, aligns well with current observations showing that the universe isn't slowing down anytime soon. It's accelerating like a rocket powered by caffeinated stardust. So here we are, caught in the cosmic crossfire between closure and endlessness. The Big Crunch is like the dramatic finale of a soap opera, while the heat death is more like an uneventful sitcom that keeps running and running. Who knew a universe so grand could have such divided contracts, regardless of which ending awaits us? It's clear that the story of the cosmos is just beginning, filled with the twists and turns that only a great cosmic narrative can deliver. Buckle up, it's going to be a wild ride through space-time. In the ever-expanding universe, space-time isn't a dull backdrop. Instead, it's a vibrant canvas constantly shifting and reshaping itself. This cosmic playground is meticulously crafted by the balance of matter and energy within it. The very shape of space-time isn't a mere mathematical doodle, but a driving force behind every dance of planets, stars, and galaxies. Imagine wide-eyed artists at work as the universe sketches out its future based on the geometric whims of its own contents. Ever pondered whether our universe is on a lifelong exercise regime? Depending on its geometry, It can stretch into an eternal cosmos, crumple like a soggy napkin into a closed-off fate, or find a happy medium, gently balancing in between. Each form, open, closed, or flat, decides how this cosmic drama unfolds. Light, galaxies, and even time itself are crafted under this beautiful geometry, like a cosmic script that governs the grand play of existence. Think back to the early universe, a time when things were a tad chaotic. Small density variations were akin to cosmic seeds, sown in the universe's fabric, which later blossomed into spectacular stars and galaxies. These tiny fluctuations, they shape the grand narrative of our universe, drawing a fascinating link between geometry and destiny. The universe is quite the storyline, with twists and turns dictated by the shape of its own space-time. Space and time are anything but passive characters in this cosmic tale. They're active participants, wielding influence and direction. Picture space-time as an artist carving its masterpiece, entirely sculpted by the interplay of matter and energy. It's not just about the birth of atoms or those distant destinations awaiting our starry-eyed future, but also how even the void is brimming with structure and potential that drives cosmic events. You might think that a vacuum is, well, empty, but let me break it to you. It's brimming with a subtle dance of activity. Modern physics reveals that even areas devoid of matter or radiation are alive with some quirky quantum traits. Imagine tiny energy pockets popping in and out of existence like a game of cosmic whack-a-mole. This fluctuation creates a bubble of background energy, intertwining with how everything operates throughout the universe. What truly blows the mind is that even the grand expansion of our universe may tie back to this ever-busy energy. The so-called empty space emerges as an intricate landscape bustling with explosions of potential. So, what appears to be a yawning void is actually teeming with hidden activities and potential, like a sidewalk cafe just before the afternoon rush hour. At the end of the day, this ocean of quantum fluctuations is constantly stirring the vacuum of space-time. Even in the absence of flashy matter and light, space harbors a restless energy, a dynamic backdrop that supports and molds all that exists. Our universe is an elaborate stage, and every little quantum wiggle adds a new thread to the tapestry of reality, knitting together all of existence in this cosmic adventure. In the zany world of quantum physics, an amusing little dance unfolds, one where nothing is ever quite still, thanks to the uncertainty principle. Imagine a cosmic party where tiny energy fluctuations surge in and out of existence like enthusiastic dancers busting a move. These spirited fluctuations conjure pairs of virtual particles that come into being, snagging a momentary energy loan from the cosmic vacuum before disappearing just as quickly. Despite their fleeting existence, these miniature marvels leave quirky footprints in the fabric of reality, subtly influencing everything from the behavior of electrons to atomic energy levels. Now, let's talk about the universe's not-so-empty void. It's a rich playground of unseen activity filled to the brim with faint radiation and ghostly particles that flutter around like the world's most elusive butterflies. Even in the sprawling emptiness between galaxies, there's more than meets the eye. This vibrant backdrop of fluctuating quantum fields ensures that every sip of space is buzzing with potential, subtly nudging particles and directing the grand dance of cosmic evolution. Who knew that even the vast expanses of nothingness were a bustling hubbub of somethingness? Though we might glance up at the starry sky and think we see serenity, there's actually a riot of movement happening in the tiniest corners of the universe, from the grand cosmic scale of expansion down to the quantum level. The vacuum isn't just dead air, it's alive with a rhythmic pulse, like a universe-wide hum you just can't hear. This is where creation and annihilation do the tango, reshaping space-time and reminding us that what we perceive as stillness is really a spectacular symphony of dynamic processes humming beneath the surface. At this microscopic level, virtual particles are the ultimate flash mobs. They pop in and out like surprise guests at a party, engaging in a hustle that exists in a blur where energy is borrowed and returned in record time. Though you can't see them, their presence is undeniable. They leave behind traces that scientists can measure, proving that even the seemingly empty spaces hold a treasure trove of secrets waiting to be uncovered. Thanks to our zippy little virtual particles, we witness intriguing phenomena like the Casimir effect. Picture two metal plates cozily snuggled in a vacuum, feeling the pressure from these elusive particles and finding themselves drawn together, a measurable force of quirky cosmic interaction. It's a playful reminder that even when things look calm and collected, there's a raucous party happening just out of sight. So, the next time you find yourself daydreaming about the vast expanse of space, remember, it's not just an empty canvas waiting for stars to paint it. Instead, it's a lively stage where subtle interactions dictate the performance of the cosmos. In a universe where every inch is energetically charged, even the quiet moments resonate with the vibrant dynamics of existence, painting a magic tapestry of entangled reality and extraordinary phenomena. Virtual particles are the cheeky little troublemakers of the universe, flitting in and out of existence, all while mediating the forces that tango in the world of electrifying electromagnetism. They're like tiny ghosts throwing a party in that mysterious realm of something and nothing. Imagine space as a cosmic stage, never a dull void but a whirlwind of activity where actual existence is just a flicker away. Like fireflies dancing in the dark. If you ever wondered how time fits into this playful chaos, you're not alone. Time, much like that last piece of pie at a party, might come in tiny, cheeky slices called quants. Some fancy theories suggest that instead of flowing smoothly, time tick-tacks ahead in these minuscule increments. Picture a cosmic stopwatch that only ticks when it feels like it, operating at a resolution so fine, it sends our regular clocks back to the drawing board. Imagine for a moment, a realm so small around 10 to the minus 44 seconds that the smooth fabric of space-time crumbles into fundamental units. If this idea holds water, everything we perceive as continuous motion could just be cleverly disguised snapshots stacked together. You know, like those magical flipbooks where every flip adds a little more life. The notion rubs excitement on our blurry understanding of how relativity and quantum mechanics could finally cozy up and become the power couple of physics. Now, let's scale down a bit more to the realm of Planck length, around 10 to the minus 35 meters. Hold on to your hats because space-time here isn't smooth like your grandma's favorite ice cream dessert. It morphs into a chaotic froth. Imagine a wild ocean of fluctuating geometries where tiny wormholes open and close like pop-up tents in a windstorm. The lines between here and there, well, good luck, they get a little fuzzy. And physicists curiously dub this delightful mess quantum foam. Understanding this frothy quagmire of creation is like chasing a mirage striving for a theory of quantum gravity, which is one of science's elusive treasures. Can you believe every solid structure you see above is merely a thin veneer over this restless tempest of cosmic craziness? If only we could grasp the full picture of how things tick beneath the surface, we might just unlock the ultimate secrets of the universe. Finally, let's settle on the concept of Planck time, the smallest slice of our cosmic pie. This infallible unit of time not only boggles our minds but sets the stage for how everything from birth stars to existing influences happens. It's a whimsical reminder that even in the grand game of existence, the tiniest seconds are the ones that hold everything together. The universe is, quite literally, a comedy of moments, a lively dance awaiting discovery. Physicists have a quirky term called Planck time, which poetically describes the smallest meaningful tick of time, clocking in at around 10:44 seconds. Imagine a time span so teeny that it makes the blink of an eye look like an eternity. Below this chirpy limit, known physics throws its hands up in confusion, and time starts to resemble a chaotic jigsaw puzzle where the pieces don't quite fit. It's as if time is having a little existential crisis, questioning its very existence. At Planck time, light can only scamper across a minuscule distance known as Planck length, which is about 1035 meters. Think of it as a cosmic ruler measuring the tiniest things that our brains can barely even wrap around. If we try to peer closer than this, we enter a realm where quantum uncertainty reigns poetic chaos, making any precise measurement as elusive as trying to catch smoke with your bare hands. It's like chasing your shadow on a windy day. Good luck with that. Now, before you think physics is all doom and gloom, let's get whimsical. In those primordial moments of the universe, time wasn't sliding smoothly like your favorite ice cream on a sunny day. Instead, it was probably hopping chaotically, ticking away in discrete little steps. This Planck time is not just a fleeting concept, it's the heartbeat of reality, the energetic thump where the cosmos sincerely starts to groove. How wild is it that even something as basic as time has its own unique rhythm? When we enter into discussions about Planck length, we're stepping into a space that's pretty mind-blowing. It's the ultimate limit where the laws of physics begin to lose their grip. Below this boundary, gravity has a big tantrum. and space stops being a comfy neighborhood. Picture trying to squeeze a marshmallow through a keyhole. It's not happening. This tiny distance stands firm as a threshold, suggesting where the known meets the great unknown. At this teeny-tiny scale, we are left pondering the immense relationship between quantum mechanics and general relativity. While quantum mechanics zooms in on the quirky antics of particles, general relativity is like the grand tour guide of vast galaxies and space-time. Each theory is strutting its stuff with style in its own corner of reality. But when they clash at extreme boundaries like near relentless black holes or the dawn of the universe, things get a bit feisty. It's as if two stellar personalities keep bumping into each other at a cosmic party. Enter the heroic quest of quantum gravity, the ultimate matchmaking service trying to unite these warring theories. Scientists are on a valiant journey to craft a universal framework that can apply to everything from tiny quarks to enormous galaxies. If they crack the code, they'll unravel one of the greatest mysteries of the cosmic book, a laughable riddle where tiny and massive entities learn to coexist peacefully. After all, how cool would it be to find a harmonious tune that resonates throughout the entire universe? Yet, despite their scientific prowess and lofty aspirations, it's a fierce battle, like a couple of headstrong cats in cardboard boxes. Quantum mechanics and general relativity have their own names on the doors but refuse to meld their ideas. Currently, their equations are like old friends who just can't see eye to eye, so close, yet so far apart. But these brilliant minds keep going, fueled by the hope that someday, the universe will share its secrets and play the ultimate symphony of cosmic unity. Researchers are diving down the rabbit hole of theoretical physics, exploring a plethora of paths such as string theory, loop quantum gravity, and the concept of emergent spacetime. Each avenue hints at a tantalizing possibility. Geometry and matter might be intertwined in ways we've only begun to understand. Cracking this cosmic code could expose the very fabric of our reality and the quirks of the universe at its wildest extremes. Talk about a cosmic puzzle that calls for a PhD plus a sense of humor. Now, toss into the ring the age-old feud between general relativity and quantum mechanics. Einstein's pet theory paints a picture of smooth, continuous space-time, while the quantum world insists on a more granular approach. Everything is made of tiny, probabilistic nuggets. When these two perspectives collide, the imagined fireworks spark contradictions that dance around logic like confused fireflies. Black holes and the Big Bang look like math problems gone rogue, conjuring infinities where normal physics simply raises an eyebrow and walks away. Despite their apparent shortcomings, physicists know their champions. General relativity and quantum mechanics are accurate within their own domains. The frustration lies in their lack of common ground when the scales flip. Picture the cosmos unfolding under a single, consistent set of laws. But so far, no one's whipped up the ideal equation to bridge this cosmic chasm. Researchers are taking to particle experiments, gravitational waves, and even the quirky territory of black hole thermodynamics in hopes of unraveling this knotty dilemma. But what if space-time itself is more like a magician's trick, a grand illusion? Some scientists are sporting wild theories suggesting that it's not the foundation of existence, but rather a construct emerging from something far more fundamental. Imagine a universe where space and time are not the ultimate building blocks, but byproducts of deeper quantum mechanics, similar to how temperature arises from the chaotic choreography of countless dancing atoms. Mind blown, right? If this theory holds water, then our perception of distance and duration may just be a collective mirage formed by an intricate web of information and entanglement. Forget the idea that space is an empty stage upon which the universe performs. This new angle portrays it as a vibrant tapestry woven from the very fabric of relationships and connections. It's like discovering that reality is less about solid ground and more about the invisible threads binding us all. This shift in perspective is nothing short of a game changer for how we understand the laws of physics. It suggests that the universe might be layered in ways previously thought impossible. Here we are, swimming through a cosmic ocean, not realizing we're on a boat made of entangled particles and quantum interactions, creating the perception of vastness and continuity around us. Who knew the universe was such a sneaky trickster? In summary, bubbling beneath the surface of our understanding lies a thrilling, chaotic dance of theories waiting for that one unifying concept to tie it all together. Scientists, armed with a blend of curiosity and scientific rigor, are racing against time to piece together this intricate puzzle of reality. The ultimate prize, a shimmering understanding that could redefine our very existence and reveal the cheeky, complex relationship between the tiniest of quarks and the grandiosity of galaxies. How's that for cosmic aspiration? Entanglement is a curious little quirk of quantum physics. Like that tangled mess of earbuds we all dread, imagine two particles, BFFs if you will, sharing an unbreakable bond that's so strong that measuring one sends ripples through the other. No matter how many light years separate them, it's like having a secret language that transcends distance, leading some physicists to think this bizarre connection might just be the fundamental fabric of space-time. Talk about a cosmic buddy system. According to this theory, there's a fascinating notion that space itself could be a patchwork quilt stitched together from networks of these entangled particles. The strength and patterns of their connections translate into the geometry of space. The more entwined the particles, the more seamless and connected our beloved universe appears. But beware, if that entanglement were to snap, space-time could quite literally rip apart or fall into chaos. Yikes. This adventurous idea offers a tantalizing bridge between quantum theory and gravity, proposing a shift from viewing space as merely a backdrop to a dynamic construct emerging from information. Picture it, our universe as a sprawling web of entanglement, where every thread plays a crucial role in holding the entire structure of existence together. The cosmos might be less of a solid place and more like a grand cosmic connection app. And the possibilities are mind-bending. Modern physics is increasingly championing the notion that information might be the true essence of reality. In some out-of-this-world theories, every tiny speck of space corresponds to a little data unit, like every pixel in a digital image illustrating the vast quantum state of our universe. These miniature bits of information whiz around, sharing energy and forming the spectacular geometries and motions we see. Even black holes join the party with their own twist, storing information not in volume but on their surface. Who knew they were such great minimalist organizers? But wait, it gets even more mind-blowing. If our universe is knitted from information, then certainly physics turns into a high-stakes computation game where every interaction between particles is a clever little calculation. In this scenario, space morphs into a glowing lattice of relationships, archiving everything we see, feel, and measure within the magnificent machinery of cosmic life. Think of it as the universe's ultimate spreadsheet, brilliantly keeping track of everything. Now, let's dive into the wild notion that time itself could emerge from this grand entanglement. Forget the traditional idea of time being the steady background on which life unfolds. What if it's the result of growing quantum connections? As different systems interact, they pull closer together in a cosmic tango, crafting a web of relationships that gets more intricate as the seconds tick away. In fact, the very increase in entanglement might just paint the picture of time's flow a swirling clock driven by the beat of quantum bonds. The cosmos is like an intricate dance, evolving from simpler steps to a chsg of complex correlations. Time, my friends, isn't a fixed dimension, it's more like the universe's way of measuring how it changes. Think of it as the cosmic gossip, where particles exchange juicy bits of information, and as they chat, space-time itself spins and twirls around them, crafting an exquisite tapestry of existence. Clocks, in this amusing tale, are less about counting seconds and more about tracking how relationships deepen over time. Picture this, while we sip our coffee, a cosmic clock ticks away, fabricating moments as it knits together entangled stories from quantum whispers. The arrow of time, sharp and pointed, sways from the neatly ordered to glorious chaos. We feel this flow in every waking moment, yet the laws of physics themselves are like impartial judges, showing no favoritism to the timeline. Why the forward push? Entropy, the mischievous culprit of disorder that keeps the universe bustling. Everything is on a journey towards disarray, and that sheet of glass shattered on the floor, let's be real, it won't magically reassemble itself. Neither will heat leisurely frolic from cold to hot without a gentle nudge of effort. In the universe's early days, things were more organized than a librarian's dream, with time having its definitive direction as entropy began its inevitable rise. This gradual ascent is what shapes our memories, instills causality, and unveils the pages of change. Now, imagine if entropy decided to have a chat with time, giving it life and momentum. Entropy isn't just some abstract statistic, it's the cosmic engine whirring away, transforming symmetry into history and pure stillness into frenetic motion. As entropy dances, it lays down the law. Time goes one way, and that's the way we happily follow. It describes, in a whimsical sort of way, how many possible arrangements a system can undertake while still keeping the same overall visage. With every tick of the clock, our universe drifts naturally toward chaos, flaunting an increase in entropy that curiously explains our perception of a forward-moving time. To reverse this process, you'd need each particle to retrace its dance steps precisely, a feat so improbable that it'd rank right up with winning the galactic lottery. Yet, this entropy-filled journey drives everything around us. From a scoop of melting ice cream to the grand swirling evolution of galaxies, they're all interconnected in a cosmic ballet. Right from the off, the universe kicked off in a surprisingly neat state of low entropy, embracing the chaotic nature that would eventually give rise to the fluid concept we call time. Thanks to this grand cosmic comedy, we experience the joy of before and after, where each event isn't just a spontaneous occurrence but rather part of an ongoing narrative that makes us ponder, laugh, and occasionally scratch our heads in disbelief. The universe is like a cosmic game of Tetris, where every piece that drops increases the disorder, from the intense explosions of stars to the rhythmic beats of our hearts. What we observe is all a part of a grand show against the backdrop of time. Imagine time as an arrow, shot forth by a bow of probabilities, always pointing toward greater chaos. Entropy, the measure of disorder, is the villain in this narrative, suggesting that if only it took a holiday, we could see time running backward, like a movie on rewind. Now, picture a world where chaos transforms into order, and broken clocks magically tick again. In this whimsical reality, the laws of physics would be tossed aside, yielding to the absurdity of causes trailing after effects. But alas, this isn't the universe we know. Such a backward existence is practically impossible because the ways for particles to fall into disorder far outstrip the few that might stumble into order. It's a statistical reality check we can't escape, making life a one-way street toward increasing entropy. Sure, there are local triumphs, like the flourishing of life, as if nature decided to have a witty comeback. Trees grow, babies giggle, and stars shine bright. But let's not kid ourselves, these bursts of order come at the price of greater disorder somewhere else. It's like when you clean your room, it looks fabulous for 5 minutes, until you trip over that mountain of laundry you shoved into the closet. The universe keeps track of this messy balancing act, making sure the arrow of time continues to fly forward. Imagine the early universe smooth, uniform, and a delightfully low entropy buffet of possibilities. Right after the Big Bang, everything was in a state of perfectly orchestrated chaos. It was an odd kind of simplicity, hot and dense, with almost no room for disorderly arrangements. But as time waltzed along, the universe expanded and cooled. Chaotic fluctuations began tossing together stars, galaxies, and planets. Each new formation threw a confetti of disorder into the mix, dancing merrily toward higher entropy levels. This spectacular rise in complexity is what defines our arrow of time. The smooth beginnings of the universe allowed for intricate structures to develop: life, evolution, change. Scientists scratched their heads, pondering why the universe kicked off in such an uncharacteristically ordered fashion. Unlocking this mystery could be the key to understanding why time has a forward trajectory at all and why our mornings are always rushed. With entropy being the ultimate culprit. It's not decay we're witnessing, it's a magnificent transformation, an ongoing tussle between order and chaos that propels the narrative of cosmic history. Every tick of the cosmic clock coincides with an increase in the universe's entropy, shaping how we perceive existence. Think of every energy conversion as a party trick that increases the mess. Each gasoline-powered engine and flickering light bulb adds a little more chaos to the universe's ever-expanding scrapbook of disorder. And so, as time zips ahead, the contours of the universe evolve, shedding light on the intricate relationship between order and disorder. Future scientists might one day unearth the secrets behind the mysterious low-entropy beginning, revealing hidden truths about existence. Until then, we can only sit back, chuckle at the cosmic chaos, and embrace every moment's delightful absurdity as entropy serves as the ultimate guide on this ride through time. Stars are the ultimate cosmic factories, fusing hydrogen into helium with the finesse of a chef whipping up a souffle. They're radiating heat into the vastness of space as if they're trying to throw the universe a big, warm hug. Meanwhile, black holes are the universe's vacuum cleaners, voraciously gobbling up everything in their vicinity: matter, light, you name it, while cranking up the entropy meter. It's like a never-ending cosmic party where disorder reigns, and the universe is just getting messier by the eon. As the universe ages, entropy becomes the life of the party, spreading its energy so thinly that most of the cosmos feels like a chilly void. We're talking cold and diffuse conditions that make a cozy blanket seem inviting. Yet, amidst this chaos, there lies a spark of creativity and complexity. The dance from order to disorder is what allows quirky systems like planets with their twisty orbits and living organisms munching on snacks to pop into existence. If only for a fleeting moment, time is ticking, and with every heartbeat, entropy leaves its mark, showcasing the universe's ever-unfolding tale. Now, let's talk about time, that tricky little rascal around massive objects. Time doesn't just move, it twists and warps like a pretzel. Gravity has this extraordinary ability to stretch time in a way that would leave even the most seasoned time travelers scratching their heads. Imagine this: clocks near a massive planet tick slower than those floating in the cosmic void. Yes, folks, it's all due to gravitational time dilation, big fancy words for what happens when you're up close and personal with something hefty like a star. This wild phenomenon has been put through its paces with some ingenious experiments, comparing atomic clocks on Earth to those zipping around in orbit. It turns out that the closer you get to that gravitational heavyweight, the more your clock feels the pull and starts lagging behind. When you've got a black hole involved, things get downright surreal. Time can stretch so much that seconds could easily feel like centuries for those watching from a safe distance. Picture this: as an unfortunate bit of matter drifts toward a black hole's event horizon, time behaves like a mischievous child, pulling pranks on everyone. To someone peering in from afar, the doomed object appears frozen in time, not moving, slowly disappearing as its light dwindles away into a reddish smudge. But for the object braving this gravity-infused roller coaster, time doesn't stop. It zips past the event horizon almost casually, blissfully unaware of the warped reality outside. As the fabric of space-time bends dramatically around these cosmic behemoths, the rules of the universe as we know them go a little haywire. The very heartbeat of the cosmos, with its complex interplay of mass and time, reveals that everything is intertwined in a dance of gravity. Each orbit, every flicker of starlight, and all the wild cosmic phenomena take place against this beautifully warped backdrop, making the universe not just a chilly place of entropy, but also a thrilling one full of mysteries and marvels. In this crazy cosmic movie, time might be elastic, with gravity pulling the strings, but it all adds an epic twist to our journey through the stars. You see, the universe might have its own agenda spreading disorder and chaos, but it also gifts us moments of wonder, making each fleeting second count in the grand spectacle of existence. So, buckle up, because as time ticks away near those captivating black holes, the entire universe unfolds a plot that is anything but ordinary. Imagine a grand cosmic dance where time waltzes at its own pace and gravity is the lead partner, shaping the universe in extraordinary ways. In the vicinity of a black hole, the very rules of time and space go all haywire. Time can stretch infinitely while motion freezes in place, creating a wild paradox where a fleeting second feels like a millennium. This region around a black hole isn't just any boring stretch of space. It's the ultimate stage for a celestial magic show. Picture the event horizon as the bouncer at the most exclusive club in the universe. Right there, gravity and the speed of light vie for control, establishing a boundary where escaping is not just difficult, it's practically impossible. As light gets dragged down, it undergoes a makeover, losing its youthful energy and being stretched out into longer wavelengths. Hello, gravitational red shift, like a laser tag game gone rogue. This clever optical trick shows us that light is not just a free spirit, it follows the curves and dips of space-time obediently, revealing how our universe is fundamentally shaped by gravity's relentless pull. Now, let's imagine observing a daring adventurer plummeting towards this cosmic black hole. From your distant perch, they seem to be playing a slow-motion game of tag with time itself. As they approach the event horizon, rather than disappearing in a flash, they fade ever so slowly, their light dimming with each approaching moment. To you, it appears this brave soul is frozen in time, stuck in an eternal struggle against gravity's tight grasp. How dramatic. But here's where it gets spicy. For the unfortunate daredevil in freefall, everything feels totally chill. They glide across the horizon without a hitch, oblivious to their audience's exaggerated perception of time. While onlookers watch their light dim, the diver feels as though they're cruising through just another day. Talk about a reality check. This wild divergence in experiences showcases the quirks of time and space under intense gravitational influence. The reality is, black holes turn out to be more than just celestial vacuum cleaners. They're reminders that time is not the dictator we often think it is. Rather, it's a flexible, shape-shifting entity that bends beneath the weight of gravity and motion. For those caught in the black hole's embrace, moments have an intriguing way of transforming into mere perspectives. Much like how tastes change with age, who even likes Brussels sprouts anymore? Thus, as we continue to gaze into the cosmic drama surrounding black holes and their event horizons, we unravel a complex tapestry woven from the threads of space-time geometry. Our understanding of the universe expands as we test the fluidity of light, gravity, and time, all enacting their own cosmic storyline. After all, you can't blame the black hole for having a reputation. It's just doing its thing, bending time and space like a cosmic Picasso, inviting us into a breathtakingly bizarre reality. Imagine plummeting into a black hole. Thrilling, right? Strangely, the experience isn't what you might think. As you cross the event horizon, there's no dramatic shuddering or jolting. Instead, it's like gliding into a brand new routine, completely casual. The laws of physics keep marching on as if it's just another lazy Sunday afternoon in space. But don't let that fool you. For those looking from afar, it's a completely different story. From the outside, when you approach that horizon, it looks like time itself is hitting pause. It's as if you're caught in a cosmic photo, frozen forever on the brink of infinity. But inside, you're just living your best cosmic life as gravity pulls you closer to the singularity, a mysterious point where even the smartest equations throw up their hands in despair while you are moving along. Observers far away are stuck staring at an endless loop of your freeze frame. These contrasting perspectives are a wild reminder of how gravity doesn't just mess with space but also bends our understanding of reality. It's a game changer. While you're feeling the thrill of gravity's pull, the angles from which people are witnessing your plunge can vary drastically. In the realm of general relativity, your viewpoint can make all the difference, a fact that could get any geometry enthusiast riled up. Take a moment to consider Einstein's insights. He flipped everything on its head, proving space and time are like rubber bands, stretchable but not absolute. If two observers are zipping through the universe at different speeds or hanging out in different gravitational fields, they'll have completely different clocks. To one observer, 5 o'clock might mean cocktail time, while for another, it feels more like déjà vu from a distant past. It's all about perspective. Now sprinkle a little relativity on top of that. Events that seem synchronized for one viewer could be out of sync for another. That mind-boggling twist stems from light speed, which insists on being the life of the party. No matter how fast you're moving, light refuses to break the speed limit. So, things like clocks and distances have to flex and contract to keep everything in balance. Life's smoother sailing until it's not. Everyday life keeps these complexities hidden like a magician's tricks, but cranking up the speed or plunging into gravity lets the rabbit out of the hat. The way we understand motion morphs into something so much richer and more intricate. There's no single, neat timeline tying the universe together. Instead, think of a web woven from all the personal stories buzzing along their individual paths, intersecting and diverging like traffic on a winding road. So, what's the takeaway? Simultaneity. Just another illusion in this enthralling cosmic game. Events that occur at the same moment for you might be on a different schedule altogether for someone else racing through the cosmos. This insanity, the relativity of simultaneity, springs naturally from the unyielding constancy of light. Welcome to a mind-bending realm where reality dances to the tune of perception. And the only constant is change. Think of the universe as a grand cosmic dance, but instead of everyone moving in sync, you've got a bunch of different dancers performing at their own rhythm. Since light has a steadfast speed, folks in various moving vessels must adjust their perceptions of time and space to keep the performance from falling apart. This means no one can agree on a universal now. Each observer carries their own funky little slice of reality based on how fast they're grooving through the cosmos. Imagine you're holding a light show while standing on a train platform. You see two flashes of light hitting the front and back of a speeding train. To your eyes, those flashes light up simultaneously, like a coordinated fireworks display. But hold on, the folks inside that train, zooming by at a different speed, will see those flashes arrive at different times. Thanks to their speedy travel, it's like trying to compare apples and oranges. But both perspectives are equally valid. This quirky scenario beautifully unpacks the essence of relativity, tugging at our intuitions about time. No longer can we just assume everything is on the same clock. The concept of simultaneity darts around like a cat on a hot tin roof. It completely hinges on an observer's motion. Time is intricately interwoven with space. They're like a cosmic pair of dance partners that can't be separated without losing the rhythm. And, surprisingly, this relativity doesn't lead to chaos but instead fosters a harmonious universe. It ensures that while we might squabble over the timing of events, all observers agree on the fundamental laws of physics. Picture it like a universal contract where everyone acknowledges the same rules of the cosmic game, even if the scoreboards display different times. Einstein stepped onto the stage of time with a revelation. Moving clocks tick differently than those parked like a lazy cat in the sun. If you're zipping through the universe at high speeds, your internal clock just can't keep up. This mind-bending phenomenon is called time dilation, and it's been thoroughly backed up by experiments. For instance, some fast-moving particles hang around much longer than they should, while atomic clocks on planes lag behind their terrestrial counterparts. But don't go thinking this is all a cosmic trick or an illusion. Nope. This ticking and tarking, stretching and bending of time is how the universe keeps everything consistent. Those time-telling devices are less about mere numbers and more about the intricate dance of nature itself. Everything must click together, albeit at different paces. It's the ultimate party trick of the cosmos. So next time you find yourself observing the shifting patterns of time and space, remember, you're not just a passive onlooker, you're an active participant in the grand opera of relativity, where laughter and skepticism swirl together like stars in the night sky. Whether you're on the ground or jetting through space, the universe embraces all of our quirky perspectives, ensuring that every tick and tack brings its own delightful twist to the story. Every observer, whether moving or still, experiences the same speed of light, an absolute constant that defies the norms of traditional physics. To accommodate this quirky truth, time decides to play the ultimate game of stretch and squeeze. As objects speed up, time for them slows down. Imagine seconds expanding like a rubber band, ensuring the universe maintains its cool harmony amid the wild antics of motion, light, and experience. And then there's length contraction, another delightful effect that adds spice to the relativity stew. Picture a spacecraft zooming at high speed. It's not just racing through space, it's also shrinking. From a stationary observer's viewpoint, the flying ruler looks shorter in the direction it moves, while time relaxes like a lazy Sunday afternoon, space pants, and shifts its lengths. This synchronized dance between time and space ensures they support one another, like two best friends at a party. Inside the spacecraft, everything feels as cozy and normal as curling up with a good book. The astronauts are blissfully unaware of the cosmic gymnastics happening outside their window. But to a stationary observer, it's a different story. Distances compress and time stretches like a well-worn elastic. This extraordinary relationship ensures that the laws of physics stay utterly stubborn and coherent across different perspectives. Experimenters have jumped into this cosmic chaos, tossing high-energy particles into accelerators. And guess what? They act precisely as relativity predicts. Let's hear a round of applause for physics. These particles whiz through their courses like race cars while their lifespans and paths conform to the mindset of relativity. Space and time twist and bend, maintaining the equilibrium that makes the universe tick just right. Now, hold on to your hats because this is where it gets juicy. When astronauts fly close to the speed of light, it's like peering through a kaleidoscope. The universe in front of them is all squished together, while back on Earth, their friends are watching those travelers' clocks move leisurely. Meanwhile, each observer holds a personal world, consistent yet uniquely different, like two sides of the same cosmic coin with their measurements dancing in perfect mirror fashion. This magical interplay between stretching time and contracting space reveals a deeper connection, sort of like a cosmic buddy system. Time and space don't flutter about like independent butterflies. They're intertwined coordinates of a grand geometry that shapes reality itself. When you rev up that speedometer, time pulls a fast one and slows, while space tightens its grip in the direction of travel, all in perfect synchronicity. The rhythm of relativity transforms what sounds like a paradox into a breathtaking symphony. It reminds us that the universe isn't just a random playground. It's a carefully orchestrated performance where the heroes are space and time, waltzing together, and through it all, the speed of light remains like a steadfast lighthouse guiding us through cosmic waters. Isn't science just a beautiful adventure? Picture this. No experiment ever reveals light gallivanting at any other speed than its fixed universal value in a vacuum. It doesn't matter if the light source is hot-tailing it toward you or taking leisurely steps away. Whether you're sprinting alongside it or just chilling in place, the result remains the same. It sounds like magic, but it's all about relativity, where space and time shake hands to keep everything in order. Now, here comes the real kicker. As objects zoom around, time decides to take a breather, slowing down, while distances shorten their skirts to match the universe's dress code. These quirky effects team up to ensure the speed of light sticks to its guns. This means the laws of nature throw a party for everyone, regardless of whether you're strolling or racing. This steadfastness makes light the VIP of cosmic communication, laying down the limits of how things influence one another. Imagine light as the ultimate messenger of the universe, swift, unyielding, and a tad secretive. Every photon sachets through a unique framework that refreshes itself, always keeping things balanced, showcasing that even the simplest constants entangle space, time, and geometry in a stunning cosmic waltz. It's like thinking you've seen a magic trick, only to find there's a deep unity beneath the surface of our reality. To make sense of this cosmic dance, physicists whip out space-time diagrams, the Google Maps of the universe, if you will. These nifty visuals plot position on one axis and time on another, turning complex equations into something you can almost touch. Each object follows a world line, a neat little path showing where and when it hangs out in the universe. Picture a stationary object tracing a straight vertical line, while fast movers lean into the horizontally, giving you a glimpse into how motion and existence twirl together. Ever noticed how light's world line creates a cosmic speed limit? Yep, even time and space have their speed checks. These diagrams allow us to see nifty things like time dilation and length contraction naturally, as though they were part of a well-rehearsed performance. Plus, they help untangle cause and effect, showing which happenings can stir the pot and which float around, forever oblivious to one another. It's relativity transformed into a visual piece of art. And then, let's chat about light cones. Think of them as the universe's social media. Every event sends out potential light paths like an announcement for a party. These crooked paths create the light cone shape, illustrating the region of space and time influenced by that event. Picture the inside of the cone as everything that can be tapped by its sway, while the outside remains a cosmic no-entry sign. In this mesmerizing web of space-time, light cones enkindle relationships between events, underscoring the very essence of how our universe operates. So the next time you look up at the stars or marvel at a setting sun, remember that you're witnessing a beautifully intricate dance of relativity, where every moment is interconnected in the grand tapestry of existence. You, my friend, are part of a universe where time, space, and light all play together in perfect harmony. Light cones are like nature's way of saying, hey, this is how causality works. They expand like your waistline after a holiday feast. The wider they grow with time, the more they encapsulate potential influences. But don't get too excited. They come with strict boundaries set by the unbreakable speed limit of light. It's a cosmic speed trap that ensures that cause must always precede effect, or else reality would just become a chaotic mess like a cat on a Roomba. Inside each light cone lies a tapestry of all the particles, sound waves, and photons that have ventured your way since your grand entrance into the world. Think of it as your personal area of cosmic influence, where every moment you've experienced has traveled within that invisible boundary, from your first cry to that awkward moment when you tried broccoli. Everything that's ever had an impact on you lies snugly within your light cone, while everything beyond, well, that's forever off limits. As time trudges along, your light cone grows, linking you to every experience you've gathered like a cosmic charm bracelet. However, don't get too carried away. Just because it gets bigger doesn't mean you can reach out and touch the stars. travel across galaxies, or you want the moments that lie just outside your light cone remain forever unreachable. It's like hanging out at a party where the music is just out of earshot. The reality is that most of the universe will always be beyond your light cone's grasp. No matter how much you yearn for knowledge or adventure, there are places and events that will never fall inside your bubble of influence. This limitation isn't due to faulty rocket ships or a lack of effort. It springs from the very nature of space-time itself. It's light's finite speed that pulls the rug from under your intergalactic aspirations. For galaxies that hang out at a distance, they're speeding away faster than light. It's as if they've booked a one-way ticket out of communication. Their light will never grace your eyes, and their histories will remain as unreadable as a toddler's crayon scrawl. Imagine waving goodbye at a galactic farewell party only to discover you're on the wrong side of an invisible curtain. What a cosmic bummer. But here's a twist to the cosmic tale. This geometric limitation serves as a reminder of the profound connections we do have, even in the face of isolation. Each of us is encased in our unique light cone, where relationships flourish, emotions tether us, and memories form the very fabric of our existence. Sure, the vastness of the universe may be intimidating, but it also makes every connection we form all the more precious, like having a hand to hold in a sea of stars. In this quirky corner of the universe, every glimmer of light and shared laughter is a bridge stretching between the finite and boundless realms, all thanks to geometry's stunning handiwork, causality. The charming little trickster hinges solely on the geometry of space-time. Unlike the deep musings of philosophers, this causal dance is grounded in spatial shapes, where cause and effect groove in a rhythmic order dictated by celestial structures like light cones. Without this cosmic choreography, chaos would reign supreme. Picture this: time and light glide gracefully through space-time like dancers at a gala. But toss in some massive objects, say, a black hole or two, and suddenly, everything's on a wild tilt. Those smooth cones stretch and fold, warping light's path and giving time a twist. Yet, even in the delightful chaos near a black hole, the prime directive still stands. Our universe keeps its quirks in check, ensuring everything unfolds in a logical fashion and nothing shimmies out of rhythm. Now, imagine the limitless potential of wormholes, those starry-eyed shortcuts in the cosmic fabric. According to general relativity, space-time isn't just a flat plane, it's a cheeky little adventurer, capable of folding itself into astonishing shapes. Wormholes, the cool kids of the universe, are akin to brief tunnels that whisk you from one corner of space to another without bothering with the long stroll in between. They may be purely theoretical, but their mathematical underpinnings tantalize the imagination. However, not all wormholes are created equal. Some sneakily collapse at the first hint of a cosmic breeze, while others strut around with a swagger, held open by peculiar forms of energy. Think of them as the universe's funky energy drinks. If we ever get our hands on one of these cosmic portals, everything changes. Distance would become a comical joke and connection, a piece of cake. Space-time would prove to be not just a backdrop, but an active player in our cosmic adventures. Take a moment to visualize a simple sheet of paper. You draw two dots on opposite ends, then fold that paper until the dots kiss. Voila! That's your wormhole, the glorious space-time equivalent of snapping two distant points together, forming an unbreakable bond. Just think how utterly delightful it would be to strut into a wormhole right outside your door, and voila, you emerge near a distant star or, who knows, perhaps an entirely new galaxy. Space-time is not just a stage, but a living, breathing entity, twisting and shaking like nobody's business. It challenges our deepest beliefs about what's separate and what's connected across the cosmos. So, with a little imagination and perhaps some advanced wormhole engineering, the universe transforms from a vast, daunting expanse into a playful maze, beckoning us to leap through and discover wonders beyond our wildest dreams. Who wouldn't want a cosmic shortcut to the stars? Wormholes, the cosmic shortcuts of our imagination, are fundamentally intriguing but undeniably tied to the property of exotic matter. This mysterious substance, if it exists, is not something you'd find on your typical supermarket shelf. Imagine material that plays hardball with gravity, acting like a repulsive force instead of the attractive pull we're used to. While we're still waiting for someone to hand us a vial of this elusive matter, the thought of traversing a wormhole to a distant galaxy does put a sparkle in the eye of any aspiring space traveler. Let's dive into the mind-bending world of quantum foam, where these microscopic wormholes might flicker in and out of existence. It's as if the universe is throwing a cosmic party, but only the tiniest guests are invited. Picture these adorable little portals dancing a waltz across the fabric of space-time, existing for only a fleeting moment. That's right, one moment they're there, and the next they vanish, leaving us mere mortals to ponder the wonders of existence while we sip our lattes. Now, if only we could make these wormholes strut their stuff on a grand stage, the ones big enough to actually serve as cosmic bridges. We're talking about intergalactic roadways that could connect different regions of the universe. These aren't just mathematical doodles. They pop up as logical results from Einstein's field equations, practically begging for a closer look. Who wouldn't want to take a shortcut through a cosmic wormhole rather than sit in interstellar traffic for light years? Still, before we start packing our bags for a trip through a wormhole, let's confront the giant elephant in the room: stability. Think of a wormhole like a precarious circus tent. Looks inviting, but might collapse just as you step inside. A wormhole bold enough to allow a human visitor would need a serious bouncer in the form of exotic matter to keep it from imploding. Otherwise, it's lights out before you can say hello, universe. Now, let's chat about this exotic matter, the superhero we didn't know we needed. Picture a substance that operates on a completely different playbook, showcasing negative energy density to battle those immense gravitational forces. It sounds like we've just stepped into a sci-fi blockbuster, doesn't it? Despite appearing in quantum phenomena, like the Casimir effect, we're still playing hide and seek with this fantastic material, as it only shows up in minute quantities. While the concept of flying through a wormhole sounds like a trip fit for movie stars, it's essential to keep our expectations grounded in reality. The extreme conditions required to create and sustain these fabulous cosmic shortcuts are well beyond what we currently understand. Nevertheless, the very possibility of wormholes invites us to stretch our imaginations and scientific pursuits, as we inch closer to unraveling the depths of both relativity and quantum mechanics. So, the next time you get lost in the wonders of the universe, consider the uncharted territory of wormholes. And who knows, perhaps one day, we'll find ourselves waving to our neighbors across the cosmic divide. Until then, we'll keep dreaming about traversing these fantastic tunnels of space-time, one quirk of physics at a time. The quest for exotic matter has physicists racing down a rabbit hole of possibilities that straddle the line between wild imagination and scientific inquiry. Picture a traversable wormhole portal like highways in space that could redefine our understanding of gravity and quantum mechanics. If they really exist, they could unravel hidden connections within the fabric of space-time, revealing remarkable truths waiting to be discovered, while leaving us wondering if we've had a few too many sci-fi movie nights. So, what holds these cosmic shortcuts open? Enter the whimsical world of negative energy. Ordinary matter woefully lacks the powers required to keep a wormhole stable, but negative energy might just be the superhero we need. This bizarre energy pops up in surprising places, like between closely placed metal plates in experiments involving quantum theory. Instead of attracting, it acts like the ultimate bouncer, pushing things away. What a twist! If we could harness this elusive energy, we might just be able to strut through a wormhole without fear of getting squished. But don't start packing your bags just yet. Despite years of intense astronomical sleuthing, no one has managed to catch a wormhole red-handed. Imagine scouring the universe for these cosmic gatekeepers only to find they may be rarer than a unicorn riding a rainbow. No eccentric gravitational quirks or eye-boggling distortions of light have thrown us a bone. Such a lack of evidence doesn't mean they don't exist, it only hints they could be hiding in plain sight, cleverly tucked away behind cosmic veils of uncertainty. Detecting a wormhole. Now that's a job for a superhero team of cutting-edge technology and eagle-eyed precision. Think of physicists peering into the depths of space-time with state-of-the-art instruments to spot the subtle wiggles that wormholes might make in the surrounding light and matter. This journey of discovery is far from monotonous. Each new puzzle piece adds to the lab-coated thrill as researchers push the boundaries of what we know, spinning the tales of gravity and geometry that could rewrite the rulebook of physics. As curiosities continue to swirl, wormholes serve as delightful thought experiments, challenging the limits of Einstein's brilliant equations. The mere idea promises a buffet of insights into the workings of the universe, from how energy bends space to the drama of cosmic interactions. The questions they raise keep the science community buzzing with energy, as imaginations run wild with scenarios of interstellar voyages and cosmic hijinks. And speaking of hijinks, let's take a detour into time travel. Some tantalizing theories suggest that not only could wormholes connect far-flung locations across the cosmos, but they might also lead us to different moments in time. Imagine using a wormhole to hop into yesterday for a do-over on that dicey haircut. The potential implications are mind-boggling, challenging our understanding of cause and effect and how we perceive time itself. Though the mystery of wormholes dances tantalizingly just out of reach, they remind us that the universe is stuffed to the brim with surprising layers of beauty and complexity. Each new revelation, even if it's just in theory, paints a picture of a reality bursting at the seams with possibilities. With every question asked, we inch closer to unlocking enigmas of the cosmos, and who knows, maybe one day, we'll find those wormhole doorways and peek through to what lies on the other side. Imagine a wormhole, a cosmic shortcut that could zip you through time like a speeding ticket on a dark highway. One end might be in your cozy living room, while the other could be suspended in the space-time continuum, making it possible for time at one mouth to crawl while the other races ahead. The thought sends shivers down your spine as it opens up tantalizing notions. Could you pop into the past to kick that embarrassing photo of yourself out of existence? Cue the mental gymnastics. Now, while some physicists are all for the dramatic flair of time travel, they're also wary of the sneaky paradoxes lurking in the shadows. Take a moment to ponder. If you zoomed back to meet your younger self, might you accidentally give your past self the wisdom to avoid that awkward high school dance? Would preventing that mortifying moment mean you'd never actually exist to spend time in that wormhole? Logic, much like an unsupervised toddler, gets pretty chaotic here. Many scientists have come up with solutions to this dizzying dilemma, proposing that the universe might have a built-in rule against paradoxes. Imagine a universe so polite it ensures that your time-traveling escapades only help the timeline rather than rewrite it. Alternatively, some brainiacs suggest that time travel could produce snazzy branching timelines or parallel realities, allowing parallel you to handle those embarrassing moments while you remain untouched in your own timeline. Spooky and exciting, right? But wait, before you pack your bags for a journey through time, there's a catch. While theorists have concocted all sorts of tantalizing models centered around curves and loops in space-time, we've yet to find physical evidence supporting their existence. It's as if the universe is playing an elaborate game of hide and seek with us, leaving us to ponder whether all this time travel chatter is, well, just chatter. General relativity graciously allows for the idea of closed time-like curves, essentially cosmic roller coasters that return to their starting point in time. Picture an amusement park ride where you can experience your past without the risk of unreachable snack bars. These closed paths might tumble from the wondrous equations of Einstein and answer the burning question: can we defy the very essence of causality and revisit our own story? While the enticing chaos of closed time-like curves arises in specific mathematical models, reality hasn't quite caught up, leaving scientists scratching their heads. Rotate those wormholes just right, and maybe, just maybe, you could hitch a ride back to your childhood and school, that cringeworthy memory. But without any sightings of such phenomena in the wild, time travel remains firmly in the realm of imagination, crazy theorizing, and spirited debates over coffee. In the end, while wormholes could act as twinkly portals linking the straightforward flow of time to the universe's hidden complexities, they also beg some serious soul-searching. Can we genuinely wrap our heads around the notion of time bending back on itself without letting our brains explode? The quest to tackle this cosmic conundrum keeps physicists busy, even when time travel trips remain firmly within the pages of science fiction. Imagine it, time loops where you can waltz back to yesterday and resolve that embarrassing moment. While scientists get excited about these ideas, many believe quantum effects or cosmic censorship keep such loops at bay. This cosmic self-preservation ensures that order reigns supreme in the universe. Yet, the concept is a delightful puzzle, revealing how time could fold and connect in bizarre ways that challenge the lines between past and future. One of the big names in this time conundrum is none other than Stephen Hawking, who introduced the idea of chronology protection. According to his theory, physics has safeguards in place that prevent closed time loops from forming. Imagine trying to create a time loop, only to have it disintegrate because the universe is like, nope, not today. the universe throws a cosmic tantrum, making energy levels spike to absurd heights, which either rips apart space-time or seals off wormholes goodbye time. Travel plans. So, what keeps causality in check? It's the universe's stubborn refusal to allow paradoxes. Even if you tried shouting at the top of your lungs, "I'm going back to fix that haircut," the consequences materialize as the universe stubbornly clings to its rules of cause and effect. Chronology protection may not be proven, but it fits snugly into the intricate puzzle of nature, ensuring that everything remains coherent even amidst chaos. But what if time is just a trick of our consciousness? Some physicists and philosophers think all moments exist simultaneously in a four-dimensional block universe. If that's the case, imagine the past, present, and future as parts of one grand time pie. Our sense of flow might just be our brains fumbling through this block, perfectly processing change like a well-rehearsed dance. Relativity adds its own twist to the story by denying any universal now. Depending on where you are, you'll perceive time differently, like a bunch of friends trying to agree on which movie to watch. Each observer slices up space-time in their own unique way. Yet the underlying events remain like a fixed geometry, orderly and unyielding. It's time travel without the time. Simply observing from different points in the eternal presence of space-time. Neuroscience jumps into the fray, showing how our brains piece together sensory experiences over fractions of seconds. So, when you feel the present, your brain is mixing and matching sensory inputs, stitching together a continuous scene that tricks you into believing in the straightforward passage of time. Memory becomes the seamstress, neatly tying together past experiences with the current moment, giving rise to the illusion of movement as you glide through life. So, the next time you wish for a time machine, remember, while the universe might be keeping strict tabs on history, our brains are busy creating a vivid tapestry. Each sec of life zips by, leaving behind sensations like a movie tightly stitched with action, prompts, and the tantalizing mystery of what's next, all while the cosmos sits back, observes, and grins. Imagine time as a quirky amusement park ride, where each moment is like a thrilling flash of flashing colors and sounds. Yet, here's the twist. What if that ride is an illusion, and we're just roaming through a grand, static landscape filled with moments? Entropy gives us a semblance of order in this chaotic flow, but the reality might be that time doesn't really move at all. Instead, our consciousness is like a flashlight, illuminating one delightful ridge of existence at a time, making us feel like we're in this constant cosmic motion. Now, let's delve into the mind-bending idea of the block universe. Picture a massive four-dimensional loaf of cosmic bread, where every crumb from the Big Bang to the twisty turns of the universe's future is baked in together. It's all there, packed tight like a time capsule. And guess what? The universe itself doesn't feel the tick-tock of time passing. It's us, the conscious beings, who do the perceiving as we zip through this time bread. Moments peel away like layers of delicious frosting, leaving us pondering, is the past, present, and future just one big cosmic pie? But hold on to your hats, because relativity has a wild card up its sleeve too. Ever noticed how your buddies now might look completely different if they're speeding by in a rocket? Different speeds lead to different experiences of time, making us question the very nature of what it means to exist. If you think about it, it's like trying to catch smoke with your bare hands. Simultaneity is nothing but an illusion that dances away when we dive deeper into the rabbit hole of space-time. So, what if we're not really watching the future unfurl into the present, then drift into the past? Instead, we're choosing our slice of the cosmic pizza, plucking memories from the fridge of the past and tossing dreams into the oven of the future. That thrilling sense of time passing is just our consciousness retracing its steps, like wandering through a dreamy landscape where everything is simultaneously present and accounted for, waiting patiently for us to notice it. Now, imagine your life as a whimsical quilt of moments stitched together with threads of perception. Each instant is as vibrant and vivid as a patch of color on that quilt, coexisting harmoniously. If we pull back the curtains, we see that the sensation of time flowing is merely an expertly crafted illusion. What we perceive as movement through time is more like gliding over a frozen lake, with our memories and expectations guiding our path through the smooth, icy surface of existence. This punchy perspective flips our everyday experience on its head, doesn't it? It brushes away the concept of linear progression and splashes a whole new painting on our mental canvas, harmonizing perfectly with the geometry of relativity. As we twirl through this kaleidoscope universe, we realize that change is relative, while the underlying structure of space-time holds every magic moment like a well-organized library. So, let's revel in the quirkiness of existence, where we're merely adventurers exploring a wild and wondrous landscape of timeless moments. Imagine space-time as a colossal, four-dimensional block, perfectly solid and utterly unchanging. Rather than envisioning the universe expanding or evolving, picture it as a single, glorious, timeless entity where every event, births, deaths, and even the cosmic dance of galaxies exists together, forever nestled in its designated spot. It's like a cosmic pizza, with every slice showing a different moment, all baked to perfection in the same cosmic oven. In this bizarre yet fascinating model, space-time doesn't play the evolutionary game. Why? Because evolution requires some sort of external time that simply doesn't exist beyond this grand structure of space-time. So, when we talk about the flow of time, we're just zipping along our world line, navigating through the fixed geometry of the universe like a roller coaster through a timeless theme park. Our experience is what creates the illusion of motion. But spoiler alert, that's just a great cosmic illusion. What's even more mind-bending is that this model explains why the laws of physics seem so darn consistent. They hold true across all frameworks, much like how your last pizza order might arrive late again. But hey, at least you know pizza will show up. The question of why time seems to march forward vanishes into the ether, leaving us with the realization that there's no actual movement in this block. Instead, our consciousness scrolls through its layers, illuminating fragments of existence as though flipping through an infinite album of snapshots already developed. Now, let's dive a bit deeper. In the most literal twist of relativity, every point in time is just as real as the next, like your aunt's embarrassing childhood photos that still haunt family gatherings. The past isn't some fading mirage, and the future isn't a blank canvas waiting for splashes of paint. They exist side by side with the present, stuck in this four-dimensional puzzle. So why do we feel like we're moving forward? It turns out, our memories serve as anchors to simpler times, giving us a delightful sense of progression that may not be as real as we think. But the equations that govern the universe don't whisper about time marching inevitably in one direction. Quite the contrary. The unfolding of events is like a scene unfolding within a still frame of geometric artistry. Each cause, effect, and outcome has already staked its claim in this intricate tapestry. And as we stand in this cosmic realm, we might feel as though we're watching life blossom as a series of sequential events. Yet in a larger context, existence is this magnificent sculpture that contains every timeline eternally etched within it. Ever thought of your sense of now as merely a sliver through that cosmic block? How about that for a thought? What we call the present moment may simply be a thin slice of space-time that our consciousness commandeers at any given vignette. So, every heartbeat, every breath we take, is simply our unique perspective of spinning through this grand and complex masterpiece of reality, a fleeting flicker in the vast and intricate lantern of existence. Picture this, a loaf of bread, each slice a moment of existence. You, me, everyone, chilling in our slice of the universe while memories connect us to the past, and our hopes project us into the future. Turns out, physics throws a party where time is a tricky guest. What's now for one observer could be yesterday's news or tomorrow's gossip for another. Quite the cosmic comedy, isn't it? Now, our brains work overtime, crafting the illusion of continuity. Our biology whispers, keep it flowing. But the universe, it could be standing around, static, with every slice already perfectly served on the cosmic table. Each observer weaves their world line through this loaf of time, intersecting with others, creating a chaotic blend of experiences, all lurking in this grand design we call reality. It's like a cosmic tapestry that's already sewn up tight. If that theory holds water, every event is etched into this cosmic slab. Consider it a four-dimensional block party, where from cosmic explosions to your next wild thought, it's all accounted for. So, while we fumble through the day-to-day, the future's already etched somewhere along our world line, just waiting to surprise us. This takes us down the rabbit hole of determinism, where laws of physics dictate the loaf's shape. But guess what? Our choices still have substance. Inside this block, We're making decisions, causing events, crafting our own little destinies even if they're pre-packaged. It's almost like our experience of free will is just our consciousness gliding through a solar system of already mapped out paths. Imagine a film reel, every frame fixed, while we zip along, relishing in the illusion of spontaneity, the plot twist, quantum uncertainty lurking in the shadows, enriching our mysterious future. Quantum mechanics add some delightful chaos to our block universe by tossing out probabilities galore. Before we peak, particles hang out in superpositions, a party of possibilities waiting to collapse into one definitive outcome. So while one might think the future is all planned out, it's really more like a cosmic lottery with a myriad of tickets waiting to be drawn. And just to keep things spicy, not all threads follow a single path in this blocky universe. Quantum phenomena suggest we might have branching options, popping out of space-time like surprise party guests. Every choice creates alternate realities, each one a slice of a much richer loaf, adding flavor to our existential journey. So who knows, in this loaf, brunch isn't just a meal, it's an entire quantum buffet. Experiments in quantum mechanics are unruly little beasts, suggesting that randomness lurks at the very core of the universe. No matter how meticulously we try to predict conditions, the results remain unpredictable, hinting that chance is a fundamental element of cosmic chaos. While Einstein's relativity gives us a tidy picture of the universe's structure, quantum theory throws in a wild card, introducing elasticity and mystery. It's as if the universe decided that spontaneity was the secret ingredient in its cosmic recipe. Enter the quirky realm of quantum mechanics, where simply observing a system gives it a makeover. It turns out that the act of watching doesn't just passively unveil the information, it actively stirs the pot, determining what gets served. Before we peer into this world, particles exist in a whimsical dance of probabilities, behaving like waves. But as soon as we take a peek, they snap into definite states, almost as if they've been playing hide and seek and suddenly realize someone's counting. The ever-popular double-slit experiment brilliantly illustrates this baffling behavior. When no one's watching, particles have a party, interfering with themselves and creating dazzling patterns, sort of like they're showcasing their wave-like nature. But as soon as we observe the particles, poof, the confusion dissolves, the waves collapse into neat points, and it's as if the particles decided their hiding days were over because someone is onto them. It's a mind-bending spectacle that reveals just how intertwined information and reality really are. Don't blink, because observers in this play aren't mere spectators, they're active participants in the unfolding universe. Every little glance or measurement we make alters the very fabric of space-time, weaving our awareness into the cosmic tapestry. Knowledge and existence are like dance partners, gracefully entwined in the grand performance of matter and energy. This reveals that what we perceive isn't just happening. It's a collaboration of reality influenced by our observations. Now, let's talk about time. As measurement expects a round of applause, it links the jagged edges of quantum indeterminacy and the unrelenting flow of time. Taking a measurement converts those hazy probabilities into clear-cut outcomes, painting the difference between what could be and what is. Before we peak, everything is a coin flip past and future all tangled up. But once we observe, bam, the moment becomes set in stone, banding together the past experiences of the universe into one big narrative tapestry. This glorious transition from indeterminacy to certainty mirrors the wild ride of entropy, where infinite possibilities contract into actualized events, leaving a delightful trail of inevitable outcomes. Each measurement we carry out seems to give us the exhilarating sensation of movement, marking the now as the bridge that connects potential future exploits to the newly minted records of history. In the midst of this cosmic excitement, some physicists speculate that consciousness might be the mysterious conductor orchestrating this grand symphony, while others counter that it's just the dance of physical interactions. Either way, we're left pondering the delicious connection we have with the universe, laughing in the face of unpredictability while embracing our role within this marvelous mystery. It's like being part of a cosmic comedy where the punchline feels just out of reach, yet tantalizingly close. Measurement dances between the quirky realm of quantum randomness and the neat order of classical physics, creating a delightful bridge that defines time's arrow. Imagine space-time not as the solid backdrop we thought we knew, but as a product of quantum correlations, like a cosmic tapestry woven from the threads of particle interactions, recent theories suggest space-time could be more of a funky emergent property, popping up from intricate networks of quantum entanglement. When particles cozy up and become correlated, their relationships might just sketch out the geometry we recognize as space and time. It's like flipping the entire script of physics on its head. Rather than saying fields are contained within the grand stage of space-time, we're proposing that space-time itself emerges from the exquisite choreography of quantum relationships. How cool is that? The very idea puts a fresh spin on our understanding of the universe and its structural mechanics. Diving deeper into the rabbit hole, simulations and hot-off-the-press mathematical models suggest that the entanglement strength of particles could dictate the curvature of the resulting space, just as mass and energy flex and shape the geometry we see in relativity. Entangled relationships might be orchestrating a similar effect at a quantum level, if this theory holds. Space-time isn't the epic fundamental player, but rather a large-scale ripple emerging from the quantum chaos underneath. Now, let's consider our perceptions of distance and time. The very moments of our lives are mere reflections of this intricate web of information binding microscopic systems. Picture the universe as a colossal spider's web, with every correlation and interaction crafting the dimensions that make up our so-called reality. It's almost poetic, don't you think? What if, on a grander scale, this universe behaves like a hologram darting out from its very edges, flipping the three-dimensional experience on its head? Enter the holographic principle, suggesting all the juicy details about a volume of space can be elegantly encoded on its outer surface. This popcorn-worthy idea gained traction through studies of black holes, revealing that the information they hold appears to swell with surface area rather than volume. If we can extrapolate this twinkling insight to the cosmos, everything from the smattering of stars to the tiniest atom might just emerge from data imprinted on a cosmic horizon far, far away. Fasten your seatbelts. Experiments in theoretical physics are uncovering tantalizing hints that support this mind-boggling perspective. While we zip through life experiencing three-dimensional depth and distance, they could simply be emergent properties akin to the surreal illusion conjured by holograms. It's like living in a holographic documentary, where the universe is simultaneously tangible and encoded, creating a dazzling show just for us. If reality is truly holographic, we are faced with a universe hiding delightful secrets beneath its solid facade, just as every tiny fragment of a hologram can reveal the entire image. Our cosmos could harbor a complete description neatly tucked away on its cosmic surfaces. So, as we look up at the night sky or contemplate our place within this mysterious expanse, remember that beneath the stars may lie a vibrant and intricate dance of information waiting to be discovered. Imagine a universe where everything is data, yes, even that pizza you had for dinner. This take on reality reconciles the big bad duo of gravity and quantum mechanics by suggesting that information is finite, not infinite. Instead of a limitless buffet of bits, reality serves a limited spread that corresponds to the area of space. Think of it as a cosmic data plan. Every little cosmic square inch comes with a cap on how much information it can hold, no matter how tempting it may be to go overboard. Now, the idea of black hole entropy enters the chat like that friend who always shows up late but has a cool story. These black holes aren't selfish vacuums that gobble things up and spit out nothing. Nope, they craftily store information on their surfaces, like a cosmic hard drive. So when matter dives in, it doesn't disappear into oblivion, it instead sends its data off to get encoded right on the event horizon. That's way cooler than those boring math problems we faced in school. Of course, all this raises some mind-bending philosophical questions. If particles, fields, and even space-time are mere shadows of information processing, what does that say about existence itself? Reality could be more than just what meets the eye. It's like peeling an onion. At each layer, you might just find patterns of information conferring true depth. Now that's a plot twist for your Saturday night contemplation. And get this, entropy, often perceived as chaos, is really just a measure of how much information gets lost or hidden. In this cosmic computation, energy swoops in like a superhero, acting as the capability to change that data. The laws of nature would make sense in a way that connects quantum theory, thermodynamics, and relativity, like a well-orchestrated jam session. It's almost as if the universe has a rhythm to it. Wouldn't you agree? So what does it all mean? If this theory is on point, then the cosmos operates on relationships, codes, and information flow, rather than just boring all matter. Imagine living in a world that's software running on a cosmic operating system. Existence could be the ultimate expression of meaning, evolving and adapting like a fine-tuned app. Just think of all the updates we might need. The triumph continues with the notion that black holes, the universe's secret keepers, may actually hold more wisdom than we thought. Instead of being enigmatic voids, they encode every bit of info on their surfaces. With a surface area that quantifies how much data they can contain, they reveal that their secrets aren't lost, they're merely waiting to be deciphered. In the grand scheme, every inch of space might contain whispers of the universe's history, like pieces of an enormous jigsaw puzzle waiting to be assembled. The amount of entropy a black hole can handle is like a countdown timer for relationships to unfold, resulting in what we consider physical phenomena. The universe, my friends, might just be one big storyline written in the most intricate cosmic code imaginable. The exciting crossroads of gravity, thermodynamics, and quantum theory unfolded a cosmic symphony at black holes. Picture them as antique archives of the universe, storing cosmic memoirs, patterns, and history itself in the fabric of space-time. It turns out that even the most gigantic black holes have their secrets stashed in their surface area, not the bulk of their mass, reshaping our grasp of the universe's laws. As Jacob Bekenstein and Stephen Hawking revealed, it's all about that outer edge, baby. Taking it up a notch, the entropy of a black hole scales with its surface area, where one might expect this to respond to its volume. This revelation shattered conventional wisdom, suggesting that as black holes balloon in size, their capacity for information inflates by the square of their radius. Who knew vast starlit voids could be so economical with their data? It even hinted at a cosmic holographic principle elevating our understanding of reality to a whole new dimension. Surfaces have the goods. Now, if you're thinking black holes are black holes for life, think again. Enter Hawking radiation, where Stephen Hawking cracked the dark code. His groundbreaking 1970s work showed that black holes have an unexpected twist. They aren't perfectly black after all. Quantum effects at the event horizon liberate pairs of particles like a cosmic magic trick, where one gets sucked in while the other escapes, whisking away a minuscule amount of energy from the black hole. Talk about cosmic drama. As time drags on, these elusive black holes start to shed weight, releasing frustratingly faint Hawking radiation. You might need a telescope the size of Texas to catch it for larger black holes, but smaller ones packing up for their final show are a whole different story. Suddenly, energy starts leaking back into the bustling theater of space-time, proving that nothing stays hidden forever in this cosmic comedy. But wait, what about the goldmine of information that black holes contain? As they drip away energy like a leaky faucet, the riddles about their contents come flooding in. Hawking's revelations twisted the very fabric of our understanding, revealing a sophisticated exchange of energy and information within these dark giants. The universe simply refuses to let anything or anyone remain isolated in their realm. In essence, black holes began to resemble celestial conduits amidst the enigmatic dance of physics. The realization that even these seemingly impenetrable beasts are engaged in cosmic chatter teaches us that the flow of information and energy never truly halts. As black holes sandwich together gravity's might, thermodynamics' charm, and quantum physics' quirkiness, they become symbols of the secrets waiting to emerge from the universe. So, as we ponder the information tucked within the folds of their surfaces, it's a reminder that the universe is anything but dull, even in the infinite dark. Bits of light or info tease, assuring us that the ultimate truths are just lurking beneath the surface, ready for the curious among us to discover. Who knew a black hole could be more than just a cosmic vacuum? Here's to diving deep into the mysteries of space and uncovering the laughter hidden in the stars. As black holes radiate away their mass, the cosmic scales tip a little differently. With every burst of energy emitted, their temperature cranks up, turning the process into a spectacular cosmic performance. Imagine a star-studded show where the spotlight shines a little brighter as the black hole prepares for its grand finale. Ultimately, it releases its remaining energy in one last hurrah, an explosion of radiation reminiscent of a dramatic confetti cannon, sharing what it borrowed from the universe. In this dazzling exit, traces of the information that once fell into the black hole may bubble up like enthusiastic party guests resurfacing from deep within. Yes, amidst all that cosmic drama, the secrecy of quantum consistency hangs in the balance. It turns out that nothing is simply plucked from existence. Instead, energy rejoins the celestial dance, keeping everything cosmic and harmonious, ensuring balance across this boundless universe of ours. Of course, while we're all rooting for these mysterious black holes to play by the rules, the specifics of their dramatic vaporization still have scientists scratching their heads. The process of a black hole's evaporation adds a splash of poetic symmetry to the chaotic world of creation and dissolution. Who knew that these seemingly sinister entities could also be the cosmic recyclers, transforming mass into light and revealing whispers of long-hidden secrets? Quite a twist in the plot. As we dive deeper, we find the mystery thickens with the infamous information paradox. You see, when our cosmic friend finally completes its evaporation, that information it hoarded must somehow resurface in its radiation. This is where things get mind-bendingly puzzling. Numerous theories speculate on how those lost tidbits could find their way back through intricate correlations within the emitted Hawking radiation. Imagine a cosmic puzzle where the pieces are scattered but always destined to fit again. What if this notion is indeed on the money? It means information is not obliterated, no way, Jose. Instead, it's transformed and cleverly packed away like treasured loot waiting for a clever archaeologist to uncover. With space-time acting like a meticulous accountant, it appears every event in the universe has a record. The tiny building blocks of quantum mechanics meet the colossal framework of cosmic structures, blending the smallest with the largest narratives in a harmonious scientific symphony. And here's the kicker. The grand conclusion of a black hole's life is anything but a vanishing act. It's a magnificent revelation, a cosmic storytelling session wherein the black hole spills the beans, recounting everything it once devoured. Engulfed in mystery and excitement, our universe eagerly awaits the tales woven into the fabric of space-time itself, a saga of cosmic rediscovery spanning eons beyond even our imagination. Fast forward to the far-off future where black holes will have delicately radiated all their mass. The galaxies that once bustled with life and energy would have transformed into shadows of their former selves. What will persist after the black holes finish their act? A vast, thin sea of energy. Picture an expansive canvas of radiant particles, stretching endlessly across an ever-expanding space-time. A tranquil yet powerful testament to the cycle of existence, as only the quiet whispers of the cosmos remain. Imagine a time when even the tiniest quantum wiggles in the fabric of reality reign supreme. Yes, my friends, we're diving into a universe where space-time is stretching like a cosmic rubber band. The universe is chilling down toward absolute zero, quite the frosty affair. Without structured matter hanging around, things start to get a bit too quiet, eventually leading to what folks call the heat death. Sounds like a bad title for a sitcom, right? But wait, there's still some cosmic jazz playing. Even in this eerie stillness, space-time hangs on for dear life. Like that last party guest who just won't go home, it's clutching the final whispers of existence. The residual vibes from the Big Bang, a quiet echo of creation before it too might just vanish into a realm beyond what physics can even whisper about. Can you imagine life as we know it just fading into pure quantum nada? Because that's one possibility. Cosmologists love to theorize about how space-time might not be the eternal buddy we think it is. If it pops into existence via quantum shenanigans, who's to say it won't just pull a disappearing act when those processes call it quits? Picture this. In the universe's grand finale, all those fluctuations just give up, and space and time themselves may disintegrate into a totally geometry-free zone. Yup, no distance, no duration. Talk about an existential bummer. But hold your horses, this quantum nothingness is anything but ordinary. Think of it as primal potential, a cosmic maternity ward, if you will, where brand new universes might be waiting to launch, each with its unique flair and laws of existence. This visual is like a cosmic merry-go-round, where space-time gets its groove on, evolves, and then says peace out, only to come back for an encore. Isn't that a wild ride? As we glide toward the end of this cosmic carnival, it feels like we've traversed the very geometry of existence. It's like following a trendy thread that reveals the beautiful connection of space and time. We've watched it twist and turn under the pressure of distant stars, performing its dramatic ballet around black holes, and stretching ambitiously with the universe's expansion, the ultimate cosmic workout. Every little flicker of light, every heartbeat of time, is sculpted by this unseen, delicate tapestry. It cradles everything from the teeniest subatomic particles to the sprawling grandeur of galaxies. All snug in its gentle embrace, we've journeyed together through this shimmering web of reality. And trust me, this is a universe that bloody well knows how to keep things lively. So what's next? An encore of existence. Perhaps, it's not really an ending but a pause before the next epically chaotic symphony kicks off. The cyclical dance of reality awaits its next spark, ready to birth fresh narratives and dazzling dimensions. As we wrap up our celestial exploration, just remember everything leads back to that singular point of possibility, where the next great adventure is just waiting to unfold. As you take a moment to unwind, imagine your thoughts slowing down like a gentle stream, mirroring the serene rhythm of the cosmos. Picture the celestial lights twinkling from billions of miles away, casting a magical glow that travels through the fabric of space. Feel that captivating hush between galaxies, where time stretches into eternity. It's a tranquil space waiting for you to relish. Now, sink into this calming imagery, where the soft pulse of time is like the quiet beat of a drummer echoing through the vastness. You're part of this cosmic dance, a tiny speck of stardust in an immense universe that has witnessed eons of history. Each moment holds the weight of the ages, and here you are, snug and cozy, connected to that ancient heartbeat of existence. If you find comfort in these contemplative travels through the universe, why not let your virtual friends join in? A little interaction can go a long way, like subscribe, or simply drop a thought below to help guide other sleepy souls to this tranquil center. One gentle nudge at a time. Who knows, someone might be seeking the very peace you're enjoying right now. Now, as you settle into this peaceful journey, focus on your breathing. Let your eyelids feel heavy, like the curtains of an evening sky gently closing over the day. Picture the universe cradling you in its embrace, a quiet cocoon filled with starlight and serenity. It's like being wrapped in an interstellar blanket, warm and comforting, reminding you that you belong to something much larger. As the stillness deepens, feel the worries of the day float away, carried off by the soft winds of the cosmos. It's a gentle reminder that you don't always need to be in the hustle and bustle. Sometimes, it's okay to simply exist in this moment. Allow yourself to drift, both weightless and timeless, in this exquisite lullaby of existence. Sleep is calling you now, like a whisper in the void, a sweet invitation into peaceful dreams among the stars. So, let go of your day's burdens, welcome the quiet, and anticipate the soft embrace of slumber. Good night, dear dreamer. May your sleep be painted with the hues of galaxy dreams, illuminating the corners of your imagination as you soar through the night sky.